Hi everyone and welcome back to my channel. So today we will have a complete marathon on step and impulse response of first order RC circuits with current excitation. If the energy source, right, input is the current, then how will the behavior of the output current and the output voltage will be with respect to the input current? That is what we will do. We will do the complete transient response. This will be hugely helpful for your interviews, for even for your written test, right? Many questions can be asked from this particular concepts, whatever we will discuss today. Also, it can be helpful for gate aspirants as well. Okay, so this marathon will be comprehensive video on transient response of all RC circuits with current excitation. So these are the circuits, right? So we have to okay, this got changed. We have to plot the voltage and current, output voltage and the output current for unit step if the current is unit step or it is a unit impulse current, and initially assumption is our capacitors are unenergized. Okay, they don't have any initial voltage, that is. So these are the circuits you can see, like we will solve a lot of circuits. These are the circuits and these four are the circuits. Okay, and these four are the last circuits. So all these we will plot voltage and current. Okay, so like the thing is I will do all this and you will see the quality of the content, the level that I will teach. You will feel it, right? You will feel whenever I am teaching something, you will feel the depth. So few things I'm asking you. Okay, just a request from my end that get this video, like if you want this video to be public, right, because it will be helpful for placements. I'm doing this much of work, so I'm expecting something in return. So make sure to like the video. If you enjoy the video, make sure to share it with your friends so that this can at least reach 1000 views, and comment down below whichever concept you enjoyed the most. Okay, so within Sunday I'm expecting all this, right? Within Sunday I'm expecting that the likes is at least 100 and views is over 1000. Okay, that is my expectation. And currently on our website discount is running. Okay, if you apply the code fusion at prefusion.in, right, you will get the gate courses at the lowest possible price. And I hope you by now you know what is the quality of our content, right? You can watch this video, you can understand how what depth we teach. Okay, we have placement courses as well, we have gate courses as well. You can check out our website prefusion.in, their discount is running. Okay, so this was about the quick announcement. So we will start with the first circuit. This is the first circuit. Okay, so the first circuit I will solve a bit slow. Okay, because maybe I have already done few marathons, maybe you have not watched my previous marathon. So this first circuit will be a bit slow. So if you already know a few things, right, you can watch this in 2x, right, or skip few portions because I have to explain, right, many things. So first circuit will be slow, then I will pick up the pace. From the circuit B onwards, I will pick up pace. So in circuit A, first of all, we will discuss whether this is a first order circuit or not. So actually, like by the title of the video, you already know that we are plotting the transient response of a first order circuits only, right? But we have to prove it, right? In the interview, they will ask you, how can you define, how can you say that this is a first order circuit? So there can be two things, right? Either you can assume a initial current or initial voltage across the capacitor. Okay, so but here in this case, I have only a single energy storing element, so I don't need to worry anything, right? If anywhere in the whole circuit, if I have only a single energy storing element, right, then the number of independent energy storing element also will be one, and if the number of independent energy storing element is 1, then the order of the circuit also will be 1. So that is the order of the circuit, order will be 1. Now if the order of the circuit is 1, then what is the transfer function? So your transfer function, right, your transfer function in this case, as the input is current, VO upon II of S, it will be a, like there will be some DC gain 1 plus S tau, but tau will be the negative inverse of the pole. Okay, so this is the this is the Laplace transform of the this is the transfer function of the whole circuit for a voltage output. Okay, for a voltage output. Now, like for the first one only I am deriving. Actually in the interview you will never use Laplace, but I have to derive, right? So I am deriving for the first circuit. From the next circuit onwards, I will not do all this, right? Only for the first circuit I am doing this. Okay, so in an interview you will actually not do this. You will only say that order is 1. Okay, you will understand once we will move to circuit B. So here I can actually do one thing. I can take the inverse Laplace. So what is my VO of S if I have a unit step input, if I am providing a unit step input, so what will be II of S? II of S will be simply 1 by S, right? If I am providing a unit step input, so it will be 1 by S into A into 1 plus S tau. Now this, right, you can break it down into partial fraction. If you break it down into partial fraction, you could take the Laplace inverse of this. If you take the Laplace inverse, your output voltage will be in the form, basically you will have a constant here C0 by S, right, minus C1 by 1 plus S tau. This will be a constant, and I know what is the inverse of this, right? Laplace inverse of this. This is simply unit step. So it comes out like your output voltage comes out to be in the form, like I am not deriving it, you can derive it, right? For the first order circuit, it will come out in the form of V0 of infinity, that will be a constant, plus V0 of 0 plus minus V0 of infinity e raised to power minus t upon tau, where tau is the time constant of the circuit. Okay, so if you don't understand this equation, you might need to study transient. Okay, minus t upon tau, because by doing the partial fraction I am able to break it down. So this will be a unit step, that is here, right? This is a unit step, and this is a simply exponential term, that is here. Okay, so this will be multiplied with a u of t. So this is how I can say that response will be exponential. So if the order is 1, right, if the order is 1, the response will be almost always exponential until certain special conditions. So we will discuss about those special conditions as well. Okay, so if this is the order, now we have found out the order, what is the time constant of this circuit? I know the order, it's a first order circuit, so time constant will be, remember, time constant will always be equals to, for a first order circuit, it will simply be R equivalent into C equivalent. Okay, so what is the, like, either the equivalent resistance seen from the capacitance or the equivalent capacitance seen from the resistance terminals. So here both are same only. So once we are actually, whenever we are talking about order of the circuit, time constant of the circuit, you have to nullify the independent energy storing elements. So what are the energy storing elements? Current source is the energy storing element. So I have to nullify, basically I have to make my II to be equals to 0. So if II is 0, that means it is open circuit, there is no current, that means it is open circuit. So here, through here there is no current, right? So then what is the equivalent resistance or capacitance? It is simply R into C. So the time constant will be simply R into C, this will be the time constant. Okay, so now let's solve the unit step response. Unit step response means I am giving a unit step as input to the circuit. So if I am giving a unit step as input, how will the circuit look just before t equal to 0? Just before t equal to 0, there is no current here, right? Because unit step means what? If I plot the unit step, how will the unit step look? Just at t equal to 0, we will give the supply, that is 1 ampere. This is my II of t, and just before t equal to 0, it is 0 ampere. So before t equal to 0, how is the circuit? So at t equal to 0 minus, this is simply open circuit, right? And we have already discussed that capacitors are initially unenergized, so there is no current through it, right? There is no current through it, right? So basically initially, as there is no current, Vc 0 minus will be equals to C dVc by dt, that is IC, C dVc, sorry, Vc. So basically there is no change in current. If there is no change in current, there will be no potential. What do I mean? So what is my V for a capacitor? Vc is C dV, sorry, what is my IC? IC is C dVc by dt. So if IC current is 0, that means here IC current is 0, that means there is no change in voltage, and initially the voltage was 0, so voltage will remain at 0. So Vc of 0 minus will be 0, that is Vo of 0 minus. Okay, now what will happen as soon as I will connect a input current here? As soon as I will connect a input current, what will happen? This source, this is at Vc 0 minus. Now I will discuss about the 0 plus. So 0 plus, right? Zero plus, I am providing a 1 ampere of current at 0, t equal to 0. And one more property of capacitor, I forgot to tell you about the property of capacitor. What is the property of capacitor? Property of capacitor is that it does not want to change its charge. It does not want to change its energy, or we can say it does not want to change its charge. So my Vc0 minus must be equals to Vc0 plus, because capacitor likes to hold its energy, it likes to hold its charge. Okay, if you don't understand this, you have to watch the transient response from prefusion, right? Network theory transient response. There we have explained all these basics. So it will like to hold its charge. It may not hold its charge if certain special conditions arises. So that also we will discuss. So here, right, Vc0 minus is what? Vc0 minus is 0 volt. That is what we discussed. It is 0 volt basically, right? So 0 volt means it will keep the same voltage at 0 plus as well. Okay. So not 1 volt, sorry, 1 ampere, right? Now this 1 ampere current, what does this 1 ampere current see? So if this is 0 volt, it is simply short circuit, right? Across this resistor as well, there is 0 volt. So there is no current through this. This whole 1 ampere will flow through the capacitor. So my IO of 0 plus is what? IO of 0 plus is simply 1 ampere. And my VO of 0 plus is same as VC of 0 plus, right? That is equals to 0 volt. Now IO of 0 plus is actually finite, and whenever your current through the capacitor is finite, the voltage will not change suddenly, it will change slowly. What do I mean by it? So if we see here, IC is what? 1 ampere, that is equals to C dVc by dt. So by dVc by dt, the slope of the voltage, right, is 1 by C, okay, which is positive. Which is positive. What does it mean? What does positive mean? Positive basically means that slowly the voltage will increase, because it was previously 0 and my rate of change of voltage is positive. That means voltage is increasing. The rate of change of the graph is positive. Voltage is increasing. Will it forever increase? Let's see. Let's take any random time. Slowly voltage is increasing. Let's take any random time, right? And let us take few values. Okay, let us take few values. Let's assume that my resistance value is 1 ohm, just an assumption, and let's take this capacitor as 1 farad, and let's assume that after a certain time the voltage keeps on increasing and voltage gets to a value of 0.5 volts. Okay, so after a certain point this voltage gets to a value of 0.5 volts. So this is at 0.5 volts, right? Now because dVc by dt is positive, that's why voltage is Vc will increase, right? So this voltage is positive, so this will be 0.5 volts. So can you tell me what is the current through the resistor now? So previously here what was the current? It was 0 ampere, because it was 0 volt here at equal to 0 plus. Here now it is 0.5 volt across the resistor, so it will be 0.5 ampere. So from here 1 ampere of current is coming, 0.5 ampere of current is outgoing. So from here 0.5 ampere of current will leave. Okay, so what has happened? Previously my IC was 1 ampere, now my IC has become 0.5 ampere. So what is IC? IC is simply C dVc by dt, which is 1 into dVc by dt, right, which is dVc by dt is equals to 0.5. So what do I observe? I observe that my dVc by dt has reduced. So the rate at which my voltage was increasing has now reduced, although it is still positive. So voltage will still increase, but not in the same speed. So the speed of charging has reduced, and it will keep on reducing till the point the whole current flows through this. Why? Because if let's say, right, after a certain point whole 1 ampere current will flow through this. If the whole 1 ampere current flows through this, the voltage here, because the capacitor, right, if I copy this circuit, capacitor can only, for now it can only absorb energy because source is present. If source was not present, then it might be able to deliver the energy, but for now it can only absorb the energy. So from here, if 1 ampere of current is coming in, right, and if this whole 1 ampere of current is coming here, so through here current will be 0 ampere, right, through here current will be 0 ampere. So if current is 0, so my IC is 0. If IC is 0 ampere, that means what? That means my CVC by CdVC by dt is 0. Now if dVC by dt is 0, right, that means my dVC by dt is 0. That means there is no change. The slope is constant. 0 means slope is constant. The slope of the voltage is constant. So my Vc is constant. Basically it is not changing with time, not a function of time, right? That's why the derivative is 0, not changing with time. That means basically we have reached steady state. When we reach steady state? When the current becomes 0. When the current becomes 0, then we reach steady state. But when will this happen? Because what will happen, this 1 ampere of current, right, initially full 1 ampere was flowing through the capacitor. Slowly this current is reducing, and this current through the resistor is increasing. This condition will happen at t equals to infinity. T equals to infinity, this condition will happen. Basically your capacitor will totally be open circuit. Now I know many students, they just mug this one up that my capacitor will be short circuit at t equal to 0, capacitor will be open circuit at t equal to infinity. And trust me, if you go by this concept in an interview, you will get simply rejected. Okay, because in today's lecture only, today's marathon only, we will see so many circuits where this will be violated. Why this will be violated? Because the current will not be 0 ampere at steady state, and initially also current will not be finite, current will be infinite. Okay, in the next impulse response only of the same circuit we will see. Okay, so just be careful with your knowledge, don't just simply mug things up, understand what is happening conceptually. So this circuit is at t equals to infinity, right? So basically I have told you that the response will be exponential, and there will be some initial value, there will be some final value, and the graph will follow this property because the differential equation follows this property. Okay, so here what is the voltages at infinity? So what are the voltages at infinity? At infinity, I can see IO of infinity is 0. VO of infinity will be what? VO of infinity will be simply whatever is the voltage across the resistor, that is 1 into R. So VO of infinity will be 1 into R, right? Because whole 1 ampere of current will flow through the resistor, none of the current will flow through the capacitor because it is steady state open circuit. So V of infinity is R. So we will plot the graphs. So IO of infinity, I know what is my IO of infinity. It is IO of 0 is what? IO of 0 is 0 plus is 1 ampere, and IO of infinity is R, and I know my time constant. So these three things only we need for a first order circuit, but it's not like always this will be the case. In the impulse response we will see, right, we may need few more information. Okay, and tau will be equals to RC in this circuit. So what will be the waveform? I will start from 1 ampere and slowly, remember my VO, right? VO will be what? VO of 0 was what? VO of 0 plus was 0 volts. Then my VO of infinity was, sorry, I of infinity was 0 ampere, and here my VO of infinity was R volts. Okay, so initially I will start with 0 volts, and then slowly the voltage will increase. Why? Because dVc by dt was positive, slowly it will increase, but the rate at which it is increasing, right, will reduce. Okay, why? Because the slope is reducing. Here let's say the slope was 40, here the slope became 30, here the slope became 20, here the slope became 0. So slowly it is going towards slope equal to 0, because at steady state dVc by dt is 0. Okay, so slowly it will go towards 0. and it will end like this, and we obviously it will reach steady state at t equals to infinity, but we say that it reaches steady state at 4 tau, because at 4 tau approximately the value reaches to 98% of its steady state value. Okay, so this will be R at infinity. Okay, and here what will be the current graph? So current initially is 1 ampere, very high current. Then slowly what is happening? Current is reducing. If you see here, right, here current was 0.5 ampere, current reduced. Again current got reduced here, right? Again current became 0. So it is starting from 1 ampere, right, and then current is going to 0. Okay, and this also will be 4 tau time, 1 ampere. Okay, and what is the equation of the current and voltage? So equation of the current and voltage, right, it will always follow this equation. We will always follow this equation for a first order circuit, but sometimes this equation will have some modifications that we will see. Okay, so what is V of IO of infinity? IO of infinity here is 0, so this is gone. What is IO of 0 plus 1 ampere? In our case IO of infinity is 0, so 1 into e raised to power minus t upon tau. So it is basically e raised to power minus t upon tau, and here what is my VO of t? VO of t will be simply VO of infinity. VO of infinity is R plus VO of 0 plus, that is 0, minus VO of infinity into e raised to power minus t upon tau. So this will be R into 1 minus e raised to power minus t upon tau. Okay, I hope this is in volts, this is in amperes. I hope here I have written minus, right? Otherwise, yeah, minus I have written. Yeah, okay. So that was the step response. Now let's discuss the impulse response. Now what is the impulse signal? Impulse signal is nothing but a very high value of infinite magnitude at t equal to 0, then it goes away. So impulse is something like this. Okay, at t equal to 0 we provide very high value and then it goes to 0, it suddenly turns off. Okay, so here what is happening? Impulse, it's current, right? It's a current impulse. Again conditions are same, that my VC0 minus is 0 volts. Okay, because t less than 0 the circuit is simply open circuit, right? Because here I see 0 minus, the circuit is simply open circuit, so this will be open circuit. This will be simply open circuit. Okay, now what will happen over here is that, so my VC0 minus will be 0, which will be equals to my VO0 minus. Now what happens at t equal to 0? At t equal to 0 I provide impulse. At t equal to 0 I provide impulse. If I provide impulse at t equal to 0, and I have told you that VC0 minus is 0, so this will behave as if it's a short circuit. This will behave as if it's a short circuit. So if it behaves as a short circuit, this is 0 volt, so no current will flow through here. Whatever current I am providing will totally flow through the capacitor. Now this is a problem. Whenever there is an infinite current in the capacitor, you will have a problem. So delta of t here, that is a big problem for us. Okay, what is the problem? The problem is, if I write the expression, what expression? IC of t equals to dVc by dt. So in this thing I get delta t equals to C dVc by dt. Okay, one more property of impulse is that if I integrate my impulse signal, right, from 0 minus to 0 plus, right, this will be simply equals to my unit step. I will not teach you signals here, just basic property you should know. So if I am integrating my impulse here, if I am integrating my impulse, if I am integrating on both sides, right, from 0 minus to 0 plus, right, of delta of t with respect to dt. This will be with respect to dt. C dv, so I am integrating on both sides, right? So this will be integration of C dvc by dt into dt. So basically I get my Vc of t becomes here, right, u of t by c. Vc of t becomes u of t by c. Okay, so the voltage like at t equal to 0 plus becomes what? Vc of t becomes u of t by c at t equal to 0 plus, because I am integrating from 0 minus to 0 plus, right, 0 minus to 0 plus. So this will be basically, like, I can write the equation. This is integration of dvc from 0 minus to 0 plus, and on the right hand side I have this integration of delta of t, that is u of t, and of course by c is there. So this will be basically Vc of 0 plus minus Vc of 0 minus, which is basically Vc of 0 minus is 0 volts, right? Vc of 0 minus is 0 volts. So it will basically be basically be 0, right? This is u of t by c. So my Vc of 0 plus is simply u of t equal to 0 plus, right? Sorry, u of t by c, u of t by c, which means what? At t equal to 0 plus, unit step behaves as 1, right? So at t equal to 0 plus, I am getting a step signal across the Vc. So Vc suddenly from 0, it suddenly change. Just in the previous slides, I have told you that Vc cannot change suddenly, but here we are contradicting. So will your capacitor behave as a short circuit at t equal to 0 plus? Will this condition be valid? No. Suddenly the voltage changed to 1 by c. So now the capacitor will be replaced with a voltage source whose value will be 1 by c. Why did this happen? Why did this happen? This happened because at 0 time I provided some charge, because what is my IC? IC is dq upon dt. IC is impulse. IC is impulse. What does impulse mean physically? Impulse basically physically means that the numerator, like, it is infinity, magnitude is infinity. That means basically at a very small time delta t, the change in charge is finite. Okay, q final minus q initial. Let's assume that initially capacitor was uncharged, so q initial was 0. So I am providing some q amount of charge, so q by delta t, where my delta t is tending towards 0. Delta t tends towards 0. So at 0 time, right, at 0 time I am providing some finite charge to the capacitor. Basically I am charging the capacitor in 0 time. I am not giving the capacitor any time, I am charging the capacitor in 0 time to like I am charging the capacitor, right? So if I am charging the capacitor, there is change in charge. If there is change in charge, we know this equation, right? Q equal to Cv. So delta Q will be equals to C delta V. So if there is change in charge, there will be change in voltage. So I am giving the capacitor some charge in 0 time. So voltage also will change in 0 time. So that's why the voltage will suddenly change from 0 to 1 by C. So it's not like always this condition will be valid, that your Vc 0 minus will be equals to Vc 0 plus. It will not always be valid. Previously it was valid because your current was finite, but here it will not be valid because your IC 0, right, the current at t equal to 0 is infinity. It is infinity. That's why it will not be valid here, because I'm providing some finite charge in no time. Okay, so that is what we are doing. So I will replace my capacitor with a voltage source whose charge is 1 by C, and of course I will have the resistor over here, that will be there. And what is the impulse signal? The current source is an impulse, right? So at t equal to 0 I provide impulse. After that t 0 plus, it is 0. So current source is 0. Simply I will remove the current source. Simply the current source will be removed. So there will not be any current source at all. No current source. Okay, this is my R. This is the circuit at t equal to 0 plus. At t equal to 0, this was the circuit. At t equal to 0, this was the circuit, and this is the circuit at t equal to 0 minus. Okay, I hope everything is crystal clear. Now this is what it is, just simply a discharging circuit. It is a source free network. Capacitor is the only source free network, and it will discharge. Why it will discharge? Because what is the current? Now what is the voltage across this resistor? It is plus 1 by C, right? So what will be the current across this resistor? It will be 1 by RC. Okay, so the current is 1 by RC. So I can see that current is leaving. My assumption was, like, whatever we will assume, right? Our standard direction of current, right, of a capacitor, if I say capacitor is charging, if this is plus minus Vc, so current should be incoming to the positive terminal, then only I can say that the voltage will increase because it is charging. So now current is leaving. Current leaving meaning it is negative, right? So if I say that this is plus 1 ampere of current, then I can say the same current like this, minus 1 ampere of current, right? So basically then I can, like, current here leaving is 1 by RC, or I can say it is minus 1 by RC incoming to the voltage source, right? So IC is negative. So IC is minus 1 by RC, that is equals to my, this is my t equal to 0 plus, right? Okay, minus 1 by RC, that is equal to my C dVc by dt. Okay, so what is happening over here? I see that my dVc by dt at 0 plus is minus 1 by RC square, which is negative. Negative meaning my Vc will discharge, basically. That is what I am trying to conclude. Vc will discharge, that is Vc will reduce. It will reduce. So let's assume again that it reduce to some value. Initially, let's say C is equals to 1, right? If I assume C equals to 1 farad, okay. So initially your Vc was 1 volt. Now let's assume that it got reduced to 0.5 volts. So if I draw the circuit again, and if I assume R to be 1 as well, so initially here what was the initial current? If I assume R, all these things to be 1, this will be 1 ampere, right? Minus 1 ampere. Now what is happening? Now if I draw the circuit again at some time, right, after some time, the voltage becomes 0.5 volts because dVc by dt is negative, so Vc will reduce. After this, what happens is that it becomes 0.5. So what is the current now? 0.5 by R. So now what is the dVc by dt? Now again 0.5 by R, or that is 0.5 only, 0.5 ampere equals to C, that is 1 dVc by dt. So this will be dVc by dt will be equals to 0.5. Sorry, minus, right? It will be minus because it is outgoing, minus, because your IC direction is, IC reference direction is this. So again it is negative only, but it has reduced. Previously it was 1, minus 1, now it is minus 0.5. So the rate at which my current voltage is reducing is actually reducing. So it will slow down, and at infinity what will happen? At infinity, I know my dVc by dt has to go to 0. The voltage shall not change. At steady state, voltage shall not change. dVc by dt must be equal to 0. That is at t equal to infinity, or at steady state, right? So basically my IC will go to 0. Basically if I replace the circuit at steady state, I will have here R, this will be open circuited, right? This will be current equal to 0 ampere, right? So voltage will be what at steady state? Vc of infinity, that is Vo of infinity, that is equals to, at steady state, what is the voltage here? Current is 0, so 0 into R is 0 volt. So Vc of infinity also will be 0 volt, Vo of infinity also will be 0 volt, Io of infinity also will be 0 ampere. Okay, and here I forgot to write few things. My, what is my Io of, what is my so this is my current, right? Output current. Okay, so at 0 minus, what is the current and voltage? At 0 minus, voltage is 0, Io of 0 minus is also 0, no current, right? Io of 0 plus will be what? From here, Vc of 0 plus will be 0, like 1 by C basically. U of t at 0 plus is 1 by C, so it is 1 by C, and my, this is equals to, this is same as my Vo of 0 plus, and my, what is my Ic or Io of 0 plus? What is my Io of 0 actually? What is my Io of 0? My Io of 0 is delta of t, because some delta current is coming, right? Io of 0 is delta of t simply. Okay, and Vo of 0 actually is at exactly at t equal to 0, it is 0 volt only, it does not change at that point of time, but at 0 plus it changes because it observes a impulse current. Now what is the Io of 0 plus? Io of 0 plus will be simply this value, right? Minus 1 by RC, minus 1 by R square C, I guess, or minus 1 by RC, whatever we derived here, right? Yeah, minus 1 by RC, minus 1 by RC. This will be my Io of 0 plus. So there are lot of things happening over here. It's not that simple. Okay, so don't just blindly remember the things over here. Okay, so here what will be the voltage waveform? So initially, let's see. So from the next circuits onwards, I will now intuitively say what is happening to the circuit. So the first circuit was slow, so I went very slow. In the next circuits, I will intuitively explain how to analyze it, how to analyze the circuit intuitively. Okay, so yeah, now what will be the current? So Io current, right? Io current will be, so we already know what is my Io of 0 minus, that is 0 ampere. Io of 0 is actually delta of t, and Io of 0 plus is actually minus 1 by RC, and Io of, okay, I am running out of space, infinity is 0 amperes. So this, all this thing will be together. So from this we can plot basically. So previously my current was 0, then at t equal to 0 we encounter a impulse. So I can show the impulse like this. This is how we show a impulse, delta of t. Okay, and then at t equal to 0 plus, it is minus 1 by RC. So current is minus 1 by RC, right? Minus 1 by RC. Okay, and then at infinity it is going to 0. Basically it will be exponential, because again it is a first order circuit, response will be exponential only. So it will reduce and it will go to 0 at photo time. So what is the time constant here? Time constant will not change. Whatever we discussed, right, that those things will not change. Time constant will be same, that is R into C. Okay, now what is happening for voltage? So let me color this thing. So for voltage, Vo of 0 minus is again 0 volts, Vo of 0 is actually 0 volts. Okay, but Vo of 0 plus, it has changed to 1 by C. Vo of 0 plus has changed to 1 by C. Vo of infinity will be again 0. So we start from 0, previously it was 0 volts only, then again at 0 equal to, it is 0 only, then suddenly at 0 plus it becomes 1 by C, it becomes 1 by C, then again it reduces exponentially to 0. So this is 1 by C, and this will go to 0 within 4 tau, very near to 0 within 4 tau time. Okay. Now here one thing you can notice, what can you notice, what can you observe is that what is this unit of this 1? This is not volt, right? So if I see my VO of V plus VO 0 plus is 1 by C. So basically how we got to that value, if you remember, there was delta of t, right? Let's say there is some A delta of t, right? A delta of t. So A delta of t was the current, right? A delta of t was the current. Let's say like delta of t has a magnitude of A, I mean not at t equal to 0, like it has a value A, right? A delta of t, that is equals to C dVc by dt. If I integrate on both sides, I will get C A upon C of U of t, right? So what is the unit of this A? That is what I want to know. So this whole unit is volts. What is the unit of this A? So what is the unit of this A? How do I find out the unit of this A? So basically what is happening, if I write this properly, my IC is equals to A delta of t, right? Or I can say IC equal to Q, some finite charge I am providing, upon delta of t, right? But delta of t is going to infinity, so basically it is some Q, here it is limit as delta of t tends to 0, so it is some Q into delta of t, correct? So basically this A, right? A has the unit of charge. A has the unit of charge. So this has the unit of charge. This much amount of charge I am actually providing to the circuit. Okay, one is the charge, whose unit is also called as volt into second. You can look it up. Okay, you can derive it. Unit will be also volt per second. So here, right, equation will not be conventional, equation will be a bit different. Okay, it will not be just V of 0 plus minus V of 0 minus, those things will not be there. So you have to be always careful. So what will be the current equation? IO of t. Current equation will be simply, here I have a impulse at t equal to 0, before that it is 0 only, so it will be delta of t, then I have a negative current which is exponentially decreasing, right? So at t equal to 0 it is 1 by RC, right? Then it is exponentially decreasing, that's why I will have e raised to power minus t upon tau, where tau is the R into C. Okay, then here what will be my output voltage? Again this will not follow the standard, like this will actually follow the standard voltage equation, because it is exponential only. So it is at t equal to 0, the value of the voltage is 1 by C, then it is exponentially decaying, so it will be minus e raised to power t upon tau, that's it. Okay, into U of t is of course there, here it is U of t, here it is U of t. So now let's derive the Bode plots for these functions, poles and zeros, right? Poles is what? Poles we have discussed, it is negative inverse of the time constant, negative inverse of the time constant. Okay, so what kind of pole I get? Negative inverse of time constant is simply minus 1 by RC, right? Time constant is RC, so it is minus 1 by RC. So my pole is here, minus 1 by RC. Now what about 0? What about zeros? So I am discussing the 0 for current. I am discussing the 0 for a current transfer function. For a resistance transfer function, I will discuss about the 0. So 0 and pole, right, depend on what kind of output and input there is. Okay, so those things depend. So here 0 means I am discussing about the transfer function, current gain transfer function, that is VO upon I of t. That is a 0, right? That is the transfer function that I am discussing. That is the pole and 0 I am discussing about. Like this is the transfer function for which I am discussing about the poles and zeros. Okay, VO upon I. What is the II of t? So sorry, not t actually. VO of S upon I of S. Sorry, I will write it properly. So Okay, so I got my pole. What about 0? So 0, right? Basically for 0, my output needs to go to 0 for a finite input. So even though there is some finite current, output must go to 0. Output volt, sorry, what I'm doing, I'm plotting for a current gain transfer function, right? So this will be IO. So my output current must go to 0 even though there is some finite input, that is current, right? So when will this current be 0? When this impedance is infinity, then all of the current will flow through here. When this impedance goes to infinity, when my S is 0. If S is 0, at S equal to 0, this branch will provide infinite impedance, so all of the current will flow through here. So at S equal to 0, I get a 0. Now for a realizable transfer function, for a real life circuit, right, your number of poles will always be greater than or equal to 0. So I have got a 0, 1 0. I cannot get two zeros because it is a realizable circuit. It is a realizable circuit, so I cannot get two zeros here. Okay, number of zeros must be less than or equal to number of poles. So we have got a 0 at S equal to 0. We have got a pole. So what will be the transfer function? Okay, so after this we need to find out the DC gain. So my transfer function, right, V of S, sorry, again I am doing V of S, I of S upon II of S will be some DC gain A upon S. I have a 0 at S equal to 0 into 1 plus S tau or 1 by S omega p, right, where omega p is the magnitude of this pole, that is RC, right. So yeah, so this will be AS upon 1 plus SRC. Now remember one thing here, although we always say that A is a DC gain, A is a DC gain, but here A is not a DC gain. What is the DC gain here? At S equal to 0, what is the DC gain? At S equal to 0, simply this is shorted. So all of the current actually flows through here, right? If I'm sorry, at S equal to 0, sorry, at S equal to 0, this is infinity. At S equal to 0, this is infinity. So no current will flow through here. So IO is 0. So actually DC gain is 0. So how will I find out the value of A? Because I know you guys mug this up that A is a DC gain. No, A is not the DC gain. A is not the DC gain. Okay. So in this case, A is actually the high frequency gain. So at DC, this will be simply open circuit, right? So there will be no current flow through this. This will behave as open circuit. Now at high frequency, A is actually high frequency gain over here. At high frequency meaning S tending to infinity. Now if S tends to infinity, what will happen? If S tends to infinity, this will behave as a short circuit, right? Because the impedance provided by a capacitance is 1 by Cs. I hope you know all these things. So this will behave as a short circuit. So all of the current will flow through here. None of the current will flow through the resistor. So my IO of S will be equals to II of S at S equals to infinity, right? So basically the ratio of IO upon II at S equal to infinity is 1. Now this A, right, is not even the high frequency gain here. It is related to the high frequency gain, but not exactly the high frequency gain. High frequency gain is 1, okay, but this A is related to the high frequency gain. So if I take this transfer function and put S equal to infinity, what will happen? The coefficients of S will be left out and the other terms will be neglected because those will be non-dominating terms. If S is tending to infinity, this term will be usually dominating over 1. So that's why I can neglect this one. Okay. So this will be A upon SS will get cancelled if I put S equal to infinity, right? Limit as S tends to infinity. This will be equals to A upon RC, which is given to me as 1. The gain is given to me 1. So A will be equals to simply RC. So finally my transfer function, right? What does my transfer function become? My transfer function becomes IO of S upon II of S is A into S, that is SRC, A is RC upon 1 plus SRC. That is what my current transfer function becomes. Right? Now we have to draw the Bode plot. So at s equal to 0, what is happening? There is no gain. If at s equal to 0 there is no gain, where will the plot lie? Will I lie somewhere around here, 0 gain? Will I lie here? Will I lie here? Pause the video, tell me, will it be in the position 1, position 2 or position 3? So if you told position 1, you need to revise Bode plots again, right? You're not studying, okay? You're not studying. So it is in dBs, and we know log of 0 is negative of infinity. So actually what will happen, I will be in the position 3. So I will start off with negative infinity, and I see that s equal to 0, we have a 0, right? So basically we will, at the starting itself, we will encounter a 0. So we know in a Bode plot, a 0 actually provides plus 20 dB per decade of slope. So I will have a positive slope of plus 20 dB per decade. So that is what my Bode gain plots, that is what my 0 provides in a Bode gain plot. Okay, then what happens at s equals to omega p, right? 1 by, like basically here at omega p, the pole, location of the pole, I encounter a pole. So initially my slope was plus 20 dB per decade due to initial 0. Now I encounter a pole, so pole will provide a additional slope of minus 20 dB per decade, but already I have plus 20 dB per decade. So overall the slope will be plus 0 dB per decade. So the value will be constant. Now the thing is whether I will stop here or stop here. Think about this, whether I will stop here or above the graph. So at this value, right, at this pole, what is the magnitude at the location of pole? That is minus 1 by RC, s equal to minus 1 by RC, s equal to s equal, I have to replace this with j omega, right? This shall be replaced with j omega, so this will be j omega RC divided by 1 plus j omega RC. Okay, so if I replace my omega to omega p, that is 1 by RC, so this will be j upon 1 plus j, right? Omega is omega p, that is 1 by RC. So it gets replaced to 1 by j upon 1 plus j. What is the magnitude? Magnitude is simply 1 upon root 2, which is actually less than 1. So if it is less than 1, then log of any value that is less than 1, right, is always negative. You can verify, log of any value that is less than 1 will always come out to be negative. Okay, so actually I will never go above this graph, I will always lie below the 0 dB axis. So the graph will be something like this. This will be the Bode gain plot. Okay, what about the Bode phase plot? Although they it's rare that they ask the Bode phase plot, but they can ask the Bode phase plot. So for Bode phase plot, two things you have to remember, that before 10 times before a pole, so if my pole is at omega p, 10 times before pole, I will start off with a slope of plus 45 degree per decade, and 10 times like this, so slope will continue till 10 times after the pole. So this slope will continue from 10 times before the pole to 10 times after the pole. It's not like at the pole the slope will change. No, the effect of 0 or pole will be 10 times before it and 10 times after it. Now what happens for a 0 at s equal to 0? So if I have a 0 at s equal to 0, 10 times before, that is 0 by 10 is 0 only. 10 times after, 0 into 10 is 0 only. So I will see the effect of 0 at s equal to 0 itself, because 10 times before, that is 10 by 10, sorry, 0 by 10 is 0, 10 times after, that is 0, 10 into 0 is 0. So I will see the effect of 0 at s equal to 0. What is the effect of 0 at s equal to 0? Basically, if you see here, if you put omega equal to 0, only this term is there, j omega, if I put omega equal to 0, right, this will be anyways go away. So it will be very low. If my omega is very low value, if my omega is very low, let's say 0.0001, okay, what you will observe is this will be 0, this will almost be 0, okay, compared to this 1, right, this 1 will be much bigger than this, so I can neglect this term, and here I will have some j into this. So basically at s equal to 0, I am getting plus 90 angle, because j provides a plus 90 degree angle. So at s equal to 0, I will get a plus 90 degree angle. Okay, so I will get a plus 90 degree angle at s equal to 0 here. Then what happens? Then we encounter a pole. Pole is somewhere here. So this will be omega p by 10 and this will be 10 omega. Sorry, one thing I made a mistake over here, sorry for that. So pole provides a slope of minus 45 degree per decade. It does not provide a slope of plus 45. I'm sorry. So the effect of pole for both a phase part will remain from omega p by 10 till 10 omega. After that, the effect of pole will go away. Okay, and it will provide a slope of minus 45 per decade plus slope. For a 0, the effect of 0 will be plus 45 per decade, and the effect will be effect will be starting from omega z by 10 till 10 omega z. So here this will be omega p by 10 omega p 10 omega p. Okay, so I will start from plus 90, then it will start reducing, it will go on till 0. Now the interesting question will be, your question will be, sir, will it stop at 0 only? Because after this there is no pole 0, so there will be no change in the phase, because effect of pole only stays till 10 omega p. After that there is no change in phase, right? Because there is no effect of pole or 0. So will it stop at 0 or will it stop somewhere else? How can you verify? So we know at infinity as well the phase will be same, that is 0, if I assume that the phase is 0. So what is the transfer function at s equals to infinity or omega equals to infinity? At omega equals to infinity, what will happen? This will get neglected. It will be j omega, that will get cancelled. It will be 1. So at omega equal to infinity, my gain is 1 plus 1. What is the phase of plus 1? 0 degrees. The phase of plus 1 is 0 degrees. So the phase here is 0 degrees. So whatever we had assumed that we will stop at 0 degrees, that assumption was correct. So this will stop at 0 degrees. Okay. So that assumption is correct, absolutely. So this will be slope of minus 45 degree per decade. Okay, and at omega p what will be the angle? Because the value reduces by 45 degree, right, every decade. So after a decade the value will be plus 45 because it has reduced by 45 degrees. This degree per decade means every decade I pass the value will decrease by 45 degrees. That is a slope. That is the meaning of slope. So now I want to plot the resistance transfer function. What if they tell you, they ask you that no, I don't want you to find out the transfer function IO over IS. I want you to find out the transfer function VO of S over VII of S, right? This is what I want. So if they ask you this, first you find out the current gain because the input is current. Then what you do? You simply do this, right? What is your VO of S? Simply it is current into the impedance. So current into impedance, that is IO of S into impedance, that is 1 by CS. Okay, that is 1 by CS. So from here I can easily find out. So what will be VO of S over II of S? That is IO of S into 1 by C of S divided by II of S. Now you are very lucky that although this is providing a pole at s equal to 0, you are very lucky that we have a 0 at s equal to 0. So there is some pole 0 cancellation. So that pole, actually the effect of pole you are not able to observe because that pole and 0 gets cancelled because you have a 0 at s equal to 0 as well. So what happens? SS will get cancelled. This will be RC and C also will get cancelled. This will be R upon 1 plus SRC. Now the Bode plot for this will be again fairly simple, right? I will not again plot it. So DC, what is the DC gain here? DC gain is R. So will it be positive or negative? So my assumption is R is greater than 1. If R is greater than 1, then the magnitude plot will be starting from above the 0 dB axis. So we will start above the 0 dB axis. So here I will not explain, right? Here I will not explain. In the previous one I explained because that was the initial one. Now I will not explain. Now you have to figure out. So at DC the gain is log of R. So this will be 20 log of, this will be 20 log of R, and at omega p, what is omega p? Omega p does not change, that is same as 1 by RC here as well. you can see the transfer function. Okay, the transfer function is this. This is my voltage transfer function. Sorry, trans resistance transfer function. Why is it called trans resistance? Because the unit is resistance, transfer resistance, output voltage, input current. So it is V over II of S. Okay. Then I will encounter a pole, so slope will reduce. It will go till what? So at s equal to infinity, what is happening? At s equal to infinity, like we don't have a zero, right? At s equal to infinity, the gain is zero. Basically, what is the omega? What is my transfer function? H of j omega. It will be r upon 1 plus j omega. So if omega goes to zero, infinity, what happens? Gain is zero. So log of 0 is minus infinity. So this slope will keep on reducing because we are not encountering anything now. So this slope will keep on reducing, go till minus infinity. So this slope is minus 20 dB per decade because I encountered a pole. What about the phase? So at at omega equal to 0, what is happening? At omega equal to 0, what is the value of the transfer function? It is plus r. R is a positive number. So phase will be initially 0. Okay. Initially the phase will be 0. Now again, omega b is here, right? Omega b is 1 by RC. So 10 times before 1 by RC, that is, let's assume that this is 1 by 10 RC, and 10 times after RC, that is 10 RC, the effect of pole will be there. That is basically, I will encounter a slope of minus 45 degree per decade. So the graph will be somewhat like this, minus 45 degree per decade till 10 RC. Then the effect of pole will also go away and the phase will remain constant. Now what will be the, can you tell me what will be the value over here? Value over here, because I have crossed 2 decades, right? And the slope here is minus 45 per degree per decade. So at RC, at 1 by RC, the slope will be minus 45 because each decade I pass, the value decreases by 45. Again another decade I will pass, again the value will decrease by another 45. So overall this will be 90, minus 90. Okay, so that will be the Bode phase plot. So now we will move bit fast now. Okay, we will move a bit fast. So this is the circuit B. So now first of all, what is the order of the circuit? Again, it's the same circuit only, just the output and the capacitor has been interchanged. So it's the same circuit. Okay, so one more thing, in the previous case, you could have simply applied the source transformation here, right? Here you could have simply applied the source transformation between your resistor and your current. Okay, I hope you know how to apply the source transformation, but I will not recommend it. Okay, because here, right, here you can do the simple source transformation, there will not be any problem. But here if you apply source transformation, there can be bit of problems. Like if you see that, if you want to apply the source transformation, that this will become plus minus, this will be like, if I convert this, its Laplace equivalent, this will be I into R, that is II of S into, like in Laplace domain you will be able to do it, but don't do it in the S domain. Basically I want to say that don't do source transformation, right? Because whenever there is capacitor, right, be careful, don't do the source transformation. If resistor is there, you do the source transformation, but if capacitor is there, avoid source transformation. So if capacitor is present, avoid source transformation. Okay, so that is one thing. Now again the same thing, how many independent energy storing elements are there? One. So order of the circuit will be 1. What is the time constant? Simple, right? RC, R equivalent into C equivalent. Here is only one R, one C is there, so it will be RC, because if I de-energize the current source, I am only observing a R and C, that is the equivalent resistors. Okay, so that's pretty simple. Now we will do the unit step and impulse response. Now we will try to do this intuitively. So let's try to analyze this intuitively. So in the previous first circuit, we did the mathematical analysis. So without doing anything, just drop the pen, just listen to me what is happening. So let's do the unit step response. So unit step means I'm providing a 1 ampere of current and initially capacitor is unenergized. So if it is unenergized at t equal to 0, 0 minus the voltage was 0 and 0 plus the voltage should be 0. Let's see if the current is finite. So if I make the voltage 0, what is happening? This is short circuit. No current will flow through the resistor. All of the current will flow through the short circuit, 1 ampere, which is a finite current. If it's a finite current, the capacitor will hold its property. It will not change its voltage instantaneously. The voltage will still be 0 volts only. Okay, but what is IC? IC is incoming, that is IC is positive. So C dVc by dt is positive. So it is charging the capacitor. So VC is increasing. If VC is increasing, this current will also slowly increase. From here 1 ampere of current is coming. This current is increasing. So IC will slowly reduce. Previously it was 1 ampere. Now it will slowly go down 0.9 ampere, 0.8 ampere. So IC is reducing. So but your dVc by dt is positive, but the magnitude of dVc by dt is reducing. So the rate of charging is reducing. So slowly what will happen? It will go towards 0, where the voltage will settle. Where will it settle? When this will be open circuit. When this is open circuit, all of the current will flow through here. So V of infinity will be I into R, that is R, and V of 0 is 0, and it will be just like a transient response. This will be the output voltage waveform. Okay, what will be the output current? Output current will be at t equal to 0. It is just the mirror of the voltage, because not the mirror, sorry, it is just the replica of the voltage, because in case of resistor, voltage and current are proportional to each other. So if you know the voltage, you know the current, right? So that's it. That's how you analyze this circuit in your head. That's how you will explain this to the interviewer. If the interviewer is telling you to go fast, if the interviewer is telling you to go slow, then you will follow the first analysis, like for the circuit A analysis, as I have explained. If like you will understand this that whether they want you to go fast or they want you to go slow. If they want you to go fast, then you will do this analysis as I have explained here. If they want you to go slow, you will do the circuit A analysis. Okay, so of course let's solve. I guess not that difficult here. So everything is already explained. So what is VC of 0 minus? I hope I don't need to draw the circuit at VC of 0 minus. It will be 0 volts only. Okay, it will be 0 volts, which will be equals to VC of 0 plus. Why it will be equals to VC of 0 plus? Because here the current IC is finite. What is the current at t equal to 0? If I draw this circuit at t equal to 0, the current will be simply, this will be replaced with 1 ampere. This will be replaced with 1 ampere. This will be short circuit. Okay, so all of the current will flow through here. So there will be no current here. Okay, there is no current here. All of the current flows through here. So what I can say is this, right? This will be, so all of the current will flow through here. So what is V O of 0 plus? V of 0 plus will be 0. What is I O of 0 plus? It is 0 only, because basically my V equals to IR. So I just need to find out the voltage. That should be enough. So I will just find out the voltage. I will go quick now. Okay, so yeah, now let's draw it at infinity. Slowly the voltage is reducing, current is reducing. Basically at infinity my capacitor will behave as open circuit. So all of the current will go through the resistor. Okay, so what will be the voltage at infinity? So this is the circuit at t equal to 0 plus. This is the circuit at t equal to infinity. Okay, so V of 0 infinity will be what? V of infinity will be simply equals to R, right? Or I of infinity also will be equals to what? I of infinity will be simply V of infinity by R, that is 1 ampere. So the So the plots will be very simple. Voltage and current plots. I will start from 0, right? V of 0 minus is 0, and then I will go to R. Time constant here is R into C, and current also will be just mirror image, not mirror, sorry, replica. This will be 1 ampere, okay, and this time will be 4 tau, this time will be 4 tau. What will be the graphs? So the graphs I of t, it is simply a exponential. Steady state it is 1 minus e raised to power minus t upon tau. So with practice, right, you will directly write it, you don't need any help. Okay, here also it will be same, r into v of t will be r into 1 minus e raised to power minus t upon tau into e of t. Okay, now let's do the unit impulse response. Let's see what interesting happens here, right? Something interesting happens or not. So again I will do the intuitive analysis. Again, draw the pen. What is happening here? Impulse current is there, right? So initially Vc0 minus is 0 because this is open circuit. So Vc0 minus is 0. Vc0, it behaves as a short circuit, so all of the current will flow through it. Now some impulse current flows through it. The current is not finite. If the current is not finite, Vc0 minus will not be equal to Vc0 plus. There will be sudden change in voltage. The voltage will suddenly increase because it is charging the capacitor at 0 time. In 0 interval, it is charging the capacitor. So voltage will suddenly increase. What will be the value of the voltage? It will be 1 by C, because integration of delta of t, IC is delta of t, integration of IC over C is the voltage, right? So it will be 1 by C. That will be the voltage developed across the capacitor. At t equal to 0 plus, this will go away because the current source will be 0, impulse is gone. This will go away. So this is charged to 1 by C, which will discharge through the resistor because this will take a current of 1 by RC. So hence the current is leaving the positive terminal, so capacitor will discharge through the resistor. It is just a source free network, so it will go to 0. That is the intuitive analysis. So V out will go to 0. V out initially will be 0 at t equal to 0, then suddenly at t equal to 0 plus, it will be a step function of 1 by C, and from 1 by C it will go to 0. That is what my V out will look like. Okay, so Vc of 0 minus will be equal to 0 volts because initially the capacitor did not have any charge, which will not be equals to Vc of 0 plus. Why it will not be equals to? Because my IC is not finite, it is infinite. Okay, because delta of t current is going. How? I can show you how. You draw the circuit at t equal to 0. You draw the circuit at t equal to 0. At t equal to 0, this is short circuit. So all of the current will flow through here, infinity current. So this is the circuit at t equal to 0. So infinite current is there. So 0 plus voltage will not be equal to 0 minus voltage. What will be the value of the Vc of 0 plus? It will be simply integration of IC over dt by C, which is basically delta of t over C, which is basically 1 by C. That will be the voltage developed at t equal to 0 plus. So at t equal to 0 plus, what will be the circuit? At t equal to 0 plus, the impulse will go away. Right, and I will replace this capacitor with a voltage source. Plus minus, this will go away, this will go circuit, and this value will be 1 by C. This will be the at t equal to 0 plus circuit. Then at t equal, like, what will be the voltage? V of 0 plus will be 1 by C. I of 0 plus will be 1 by RC because it is just a resistor. What will be the circuit at t equal to infinity? Current will be 0, right? It is a source free network, so it will go to 0. So here the current will be 0, so this will behave as open circuit. So if the current is 0 ampere, so the drop also is 0, right? Current is 0, so VO of infinity will be 0 volt, IO of infinity will be 0 ampere. Okay, so what is happening over here? So initially my voltage was 0, then suddenly I received a impulse, due to which suddenly the voltage increased to 1 by C, then again it will go to 0 for tau. Okay, and here my IO, right? IO will just follow the voltage, just a resistor will be there, that's it. This will be 1 by RC. Now what will be the transfer function? Fairly simple transfer function. I will directly do it now. So what is the pole? Pole is same, right? SP is 1 minus 1 by RC, right? Omega P will be 1 by RC. This is the pole. What about the zeros? So zeros will be what? Zeros. Do I have any zeros? Can my current go to 0? At S equal to infinity, my current can go to 0, but that is not a finite 0. So no finite 0, right? So what is the DC gain? At S equal to 0, what is happening? This is behaving as a infinity. All of the current is flowing through here. So my IO of S, right, is simply equals to II of S at S equal to infinity. Okay, so IO of S over II of S equals to 1. Okay, that is the DC gain. Basically this is the DC gain. A is DC gain. So my transfer function will be what? High frequency gain is simply 0. So my transfer function, right, H of S, it is A, there is no 0, 1 plus S upon omega P, which is equals to 1, DC gain is 1 plus SRC, 1 by 1 plus SRC, that is my DC gain basically. Okay, so how can I, what can I do to plot it? It is very simple, right? So my transfer function is this. I don't think there is much debate. Transfer function is this, right? It's pretty straightforward transfer function. There should not be any difficulty in plotting this, right? So this will be simply a pole at 1 by RC, right? And at S equal to 0, the gain is 1. So in dB scale, it is 0 dB. So I will start off with the 0 dB axis, and then I will go to the, I will encounter a pole. So the slope will be minus 20 dB per decade. It will always go down. So I will start off with 0 dB axis, because the gain is 1 at S equal to 0. So log of 1 is 0. Then I will encounter a pole. Okay, and it will always be negative. Okay, so this will be my minus 20 dB per decade after the pole. What will be the phase? So at S equal to 0, the gain is plus 1. Plus 1 means it has a phase shift of 0 degree. So again, I will start off with 0 degree, then 10 times before the pole, that is 1 by 10 RC, and 10 times after the pole, the effect of pole will be there, right? That is, I will get a slope of minus 45 degree per decade. Okay, and then the value of the phase will just remain constant, that is minus 90, right? Same thing, I will not explain over again how it came minus 90. It is the same. So this will be my RC at pole, exactly 1 by RC, it will be minus 45. This slope will be minus 45 per degree per decade. What will be the resistance transfer function? It is very simple. This time my VO of S is simply R into IO of S. So what I will do is I will multiply and divide. So okay, I know my, so my V of S is R into IO of S. I know my IO of S by II of S is equals to what? 1 by 1 plus SRC. So here, right, I will replace my IO of S with VO of S. Okay, sorry, I need to find out my V of s by II of s. So we'll replace this with R into IO of s by II of s. That will be simply R by 1 plus SRC. So basically what will happen, the gain plot will just shift upwards if R is greater than 1. Other than that, there is no difference. So gain plot will just shift upwards by 20 log R. Okay, that's it. Everything else will remain as it is. So this will be 1 by RC. This now this value will not be 0 anymore. This will be 20 log R. Don't have space. 20 log R. Phase plot will not change at all because we are just changing the magnitude. Phase does not have any effect. Okay, 1 by RC, 1 by 10 RC, 10 RC. Okay, now let's move on to the this circuit. So if I see how many number of independent energy storing elements are there, only, like I have only one energy storing element, so number of independent energy storing element also will be only one. Okay, so this will be one. You can apply source transformation, but I will not recommend doing that. Now what will be, it is a first order circuit. If I have only single independent energy storing element, so it's a first order circuit. What is the time constant? What is the time constant now? Time constant is R equivalent into C equivalent, right? So I will find out the R equivalent across the C because I have only a single capacitor. So I have to first of all nullify the independent energy storing, independent sources, sources. So current is a source, so I will nullify that. Then I will find out the equivalent resistance across the capacitor. So what is the equivalent resistance across the capacitor? It is simply, remember this is open, right? So this is 0 amperes. So from here these two are in series. Whatever current is flowing out of this resistor, same current will flow out through this resistor. It is not in parallel. Okay. So here R equivalent will be 2R. So C equivalent is C only because it's a single capacitor only, 2R into C. That is R equivalent into C. That is my time constant. Okay, 2R into C. Now let's do the step and impulse response. First of all, I will explain intuition. So what is happening here at t equal to 0 minus, right? There is no energy, so this will have zero potential, and this is also gone. T equal to 0 minus, current is 0, right? It's a unit step function. This only comes into action at t equal to 0. So t equal to 0 minus, this voltage is 0. Now what is happening at t equal to 0 plus? So this will behave as a short circuit. If this behaves as a short circuit and I am providing a 1 ampere of current here, it is observing R and R ohms. So it will get equally divided, half and half. So IC is equals to half, which is finite. So we have a finite current. If we have a finite current, that means the voltage condition will hold, that it will hold its property, VC0 minus will be equals to VC0 plus. Okay, it will hold its property, so it will not change. So it will still be 0, but current is positive, so voltage will increase. Slowly it will energize till what? At infinity this will behave as an open circuit. So if it behaves as an open circuit, all of the current will flow through this. So this voltage will become R. So this current is 0. So VC infinity will become R at steady state. Okay, that is equals to my VO infinity because current here is 0. Okay, I hope that is clear. So that is the intuition basically. That's it. Now let's solve it. So VC0 minus is 0 volts, which will be equals to VC0 plus. Why it will be equal? Because my current is finite. Basically my IC0 is finite. That's why it will hold its property. So what is IC0 basically? So if I draw the, so what is VO0 minus? Remember now VC and VO are not same anymore, they are different actually, because VO is a combination of resistor and capacitor. So VO actually, VO of t will be IC of t into R plus VC of t. Okay, this is what my VO of t is. VO of 0 minus is 0 actually, because IC of 0 minus is also 0, because there is no current here, it is 0, and VC of 0 minus is 0. So that's why VO of 0 minus will be 0. Now what will be my what will be my 0 plus, right? What will be my VO of 0 plus? For that I need to draw the circuit. So this will be 1 ampere, and this is at t equal to 0 plus, and capacitor will behave as a short circuit at t equal to 0 plus, right? So through here half current will flow, so through here half current will flow. So what will be my VO of 0 plus? VO of 0 plus will be simply 1 by 2 into R, right? Because VC of 0 plus is 0, so it is R by 2. And what is my IO of 0 plus? IO of 0 plus 1 by 2 ampere. Okay, that is what my IO of 0 plus is. So I hope VO of 0 plus is clear. Now what I have to draw the circuit again at infinity. At infinity my capacitor will behave as open circuit. Okay, so through here zero current will flow, all of the current will flow through here. So the drop across the, so IO of infinity is simply 0, VO of infinity will be also 0. No, it will not be 0, right? Because it will have some potential. It's not like capacitor is open circuit, it does not have any potential. Open circuit does not mean voltage 0, open circuit means current is 0. How do I find out the potential? So this drop is 0, but this has a drop, right? And VO is basically the voltage across this resistor, right? This point is same. So what is the drop here? 1 ampere of current is flowing through this resistor, which is R. So this will be R volts. Okay, R will be the VO of infinity. We can simply draw the circuit. So at t equal to 0, the current IC is going to half, right? Suddenly the current is changing to half, before it was 0, and then it is reducing to 0 amperes. Okay, at 4 tau, what is the tau now? Tau now has changed, it is 2 RC, and the voltage is interesting. So 0 minus voltage was 0 only, then suddenly it increased to R by 2, then it increased to R in the time 4 tau. Okay, so increase to R 4 tau, R by 2 tau. Okay, that is what my VO of infinity is. I hope it is clear. I'm correct, right? Initially the voltage was R by 2. Yeah, initially the voltage was R by 2. Fine. Okay, so now let's discuss the impulse response. What will be the impulse response? So okay, before that I will draw the, like, I will write down the equations. This I of t equation will be 1 by 2 e raised to power minus t upon tau, and this VO of t equation will be so now I will use that standard equation, because I directly will not be able to write it, the equation, right? I will use that standard equation. What is the standard equation? It is VO of infinity plus VO of 0 plus minus V of infinity. I will directly not be able to write it, so I will take help of the standard equation into e raised to power minus t upon tau. So this will be V of infinity. V of infinity is basically r plus r by 2 minus r into e raised to power minus t upon tau. Okay, so this, right, this will become this. If I take the r common, this will be 1 minus e raised to power minus t upon tau divided by 2. Okay, that is what my current equation will become. Okay, so I hope it is clear now. So now let's do the impulse response. So again, if the impulse response, what is happening at 0 minus, voltage is 0, at 0 plus, this is behaving as a short circuit, so both of them are providing a R impedance, right? Both of them are providing R impedance to this current source, so current will get divided. So through here delta by 2 current will flow, through here delta by 2 current will flow. Again some infinite current is flowing. Delta by 2, infinity by 2 is infinity, infinity into infinity is infinity, infinity into 2 is infinity, infinity minus infinity is infinity, infinity by 10 is infinity, so it does not matter. So infinity current is flowing through the capacitor, it will not hold its property. Vc0 minus will not be equal to Vc0 plus. There will be some step voltage that will be developed across the capacitor. Okay, that will be developed across the capacitor. So this voltage will become some step. After that, this impulse will go away, current source will go to 0. So now this will act as an energy source, and this will behave as a source free RC network. So this will just discharge exponentially. Okay, that is the intuition of this whole circuit, and it will discharge to 0 voltage, 0 voltage, 0 current, everything will be 0 because it is a source free network. Okay, so let me write Vc0 minus is 0 only because initially there is no charge, but it will not be equals to Vc0 plus because my IC0 is not finite. So what is my IC0? Draw the circuit at t equal to 0. So this will behave as a short circuit. Okay, so this will provide a impulse current. So again it is observing equal resistance delta t by 2 t by 2. Okay, so infinite current is flowing, so IC of 0 is actually delta t by 2. So what will be the voltage developed? What will be Vc0 plus? It will be 1 by C of integration of delta t by 2 dt. So it will be actually 1 by 2C now. It will not be 1 by C, it will be 1 by 2C because it is delta t by 2. Because the amount of charge has reduced. Previously I was providing 1 coulomb of charge, that is delta into t. Now I am providing delta t by 2, so I am providing half coulomb of charge. Although like infinity, it is infinity, I agree. The current is infinity, but charge has reduced. Current is infinity, charge has reduced. So right now I am providing half coulomb of charge. Okay, so if I draw the circuit at t equal to 0 plus, t equal to 0 plus, this will go away, this will be replaced with a voltage source. that is 1 by 2c. Now what is the current? So I have not here discussed what is the voltage. So v of 0 minus is what? Again v of 0 minus, here the current is 0, so automatically this drop is also 0. It is vc 0 minus, which is equals to 0 volts. What is v? So let me draw the circuit at 0 plus. What is vo 0 plus, right? For that I just, v of 0 plus will be what? What is v of t? Basically v of t is again the same thing, I of t, I into r plus ic into r plus vc of t. Okay, that is what my voltage is equals to. So what I can say is, what will be v of 0 plus? V of 0 plus will be ic of 0 plus into r plus vc of 0 plus. I know what is vc of 0 plus, that is 1 by 2c. What is ic of 0 plus? What is ic? So ic, remember, is in this direction. ic, remember, is in this direction, right? But actually where is the current flowing? Current is flowing in opposite direction, because this will deliver the current. What is the value of the current? ic of 0 plus will be, what is the value of the current that it will deliver? From here 0 amperes of current is going, right? All of the current will go through here. So these R and this R is in series. So it is 1 by 2C upon 2R. So it is basically 1 by 4RC. Okay, that is the current. Now current is this negative, because my reference IC direction is in this downward, but actually current is flowing in the upward direction, so I have to choose current to be negative. Okay, so it is minus 1 by 4RC. What will be the voltage? So voltage I can put it over here. It will be minus 1 by 4RC into R plus VC of 0 plus, that is 1 by 2C. So this will be equals to minus 1 by 4C plus 1 by 2C. So this comes out to be 1 by 4C. So VO of 0 plus actually comes out to be 1 by 4C. And what is happening at infinity? Infinity, everything will get discharged. If I draw the circuit, so this is the circuit just at t equal to 0 plus. At infinity, remember this is the circuit at t equal to 0. Okay, t equal to 0 and 0 plus are two different things. Okay, so at infinity what is happening? At infinity, if I draw the circuit, right, everything will be gone. This will behave as an open circuit because steady state has been reached, that is my dVc by dt will be 0, so there will be no change in voltage, so IC will be 0, so it will behave as an open circuit. So basically this current will be also 0, so this drop is equals to my VO, so IO is 0, IO of infinity is 0 amperes and VO of infinity is also 0 volts. So how will the circuit look? So for the voltage waveform, VO of 0 minus is 0, then suddenly I get a step, right? What is the VC of 0 plus? VC of 0 plus is 1 by 4C. So we will get a 1 by 4C voltage, sudden increase, and then it will just decay down. In photo time, tau is 2RC. This will be photo time. Okay, and then here what will happen is, what about the current, right? Initially current is 0 minus, then I encounter a impulse. What is the area of the impulse? Area of the impulse will be delta t by 2, not delta t by 2, because there is some current division happening. Then the current is negative, minus 1 by 4RC, current is negative 1 by 4RC, then it decays down to 0. Okay, so let me write down the equations. So equation for current will be delta t by 2, then minus 1 by 4RC into e raised to power minus t upon tau. And here the equation, this is the equation of the current, this is the equation of the voltage. So the equation of the voltage is equals to 1 by 4RC into e to minus t upon tau. Okay, 1 by RC, 1 by C minus t upon. So what is the current gain now? Current gain transfer function. So pole, what is the location of the pole? Pole will be minus of inverse of time constant, which is basically equals to minus of 1 by 2 RC. So my omega P will be 1 by 2 RC, right? This is my pole. What is my 0? What is my 0? So my 0, I can see 0, right? For 0 current to go to 0, this has to provide infinite impedance. All of the current should go to here. So at s equal to 0, I am observing that this is going like this, impedance is infinity. S equal to 0, this impedance is infinity. So all of the current will flow through here, right? So IO is going to 0 at s equal to 0. So s equal to 0, IO of s is simply 0 ampere, right? So 0 at s equal to 0. So how does my transfer function look? My transfer function will be sum a s divided by 1 plus s 2 RC, because the pole is now 1 by 2 RC. Again, a is not even the high frequency gain, not even the DC gain. Okay, a is nothing, a is just a number. So now we will see what is the DC gain. DC gain is simply 0, because at s equal to 0, right, s equal to 0, your h of 0 is simply 0, because your IO of 0 is 0, right? What about the high frequency gain? High frequency gain, right, if I from high frequency gain we will be able to find out our transfer function, basically value of a. So my h of s is this value, right? This is my h of s, which is h of, so what is the h of infinity? H of infinity will be, I will just take the coefficient of s, right? I will just take the high weightage terms coefficient of s, so that will come out to be a upon 2 RC. And from the circuit, if I put s equal to infinity, this will behave as a short circuit, right? It provides impedance of 1 by Cs, so this will behave as a short circuit. So my IO of s by IO of s, it is just a current division, that is equals to 1 by 2. So this will be equals to my 1 by 2. So from here I can directly say my A is simply equals to RC. Okay, so my transfer function h of s will be SRC. S to RC. Okay, so here what will be the Bode gain plot? So Bode gain plot, right, at s equal to 0 I have a 0, so it will start off with a positive slope, correct? And what about, so what is the gain near 0? Gain near 0 is 0, so it will start from negative infinity. I'll start off from negative infinity, right, and I will have a 0, so the 0 will be plus 20 dB per decade. Now at pole, what is the magnitude at pole? That is 1 by 2 RC, right? The magnitude is, so what is h of j omega? Is j omega RC divided by, so here, right, I will put my magnitude of transfer function. that will be at omega equals to 1 by RC, right? Omega equals to 1 by RC, this will be equals to 1 by, so j upon 1 plus j2. So magnitude is actually magnitude of this, right? Magnitude will be somewhat, sorry, j upon 1 plus j, right, will be basically 1 by under root of 2, that is less than 1. If it is less than 1, I will lie below the 0 dB axis, okay, because here I will encounter a pole, so that's why the overall slope will become, overall slope will become 0 dB. Previously the slope was plus 20 dB per decade, here the slope is 0 dB per decade. Okay, what about the Bode phase plot? So phase plot, right, again I am encountering a 0, right, at s equal to 0. So 10 times before the 0, that is 0 only, 10 times after the 0, the effect will be plus 90, because I am getting encountering a 0 at s equal to 0. So the angle at omega equal to 0 will be plus 90. So this will be plus 90 at omega equal to 0. Then I encounter a pole, so 10 times before the pole, that is 1 by 5 RC, right, and 10 times after the pole, that is 20 RC. The effect of pole will be there, it will be minus 45 degree per decade, and it will go to 0 degree. Why? I hope I don't need to explain. Okay, so this will be, the slope will be minus 45 degree per decade. This will be 1 by 2 RC. This will be 45 degree. Okay, so now let's do it for the trans resistance. Okay, trans resistance will be kind of difficult here, because, right, like trans resistance is the homework for you. This is the homework for you, you do it, right? How will you do it? So basically what you need to do is you just need to multiply the, so okay, let me do it. Let's not give you homework, let me do it only. Okay, so if I take this circuit, yeah, this one, right. So what will be my V of S? But basically I need to find out V of S over I of S, right? So what is my VO of S? V of S is simply equals to I of S into whatever is the impedance. What is the impedance here? R plus 1 by CS. R plus 1 by CS, or this will be equals to IO of S will be equals to 1 plus SRC divided by SC. Okay, now okay, now I will do that, right? So here V of S over I of S will be I of S into this value divided by I of S. So I of S over I of S we have calculated, that is SRC upon 1 plus 2 SRC. So SC will get cancelled. This will be R into 1 plus SRC upon 1 plus 2 SRC. Okay, so that will be the transfer function, and I hope now you can plot. So at s equal to 0, what is the gain? Gain is r. So gain is r. So the border plot will be somewhat like this. I will directly draw the border plot now. This will be s equal to 0. I will encounter a, so this right, I need to shift it bit right. What? Like the DC gain will be r. So it is, assumption is it is greater than 1. So it will be above the 0 dB axis. Now where is the 0 here? So omega z is 1 by rc and omega p is 1 by 2 rc. So I encounter a pole first, then I encounter a 0. So first I will encounter a pole. So what is the effect of pole? Pole provides a slope of minus 20 dB per decade, right? And then I encounter a 0. Okay, I will encounter a 0 that will provide a slope of plus 20 dB per decade, but as I already have minus 20 dB per decade, so overall slope will become 0 dB per decade. Here this will be 1 by rc. This will be the 0. Now will this value lie above the 0 dB axis or below the 0 dB axis? How can I identify? So what is the high frequency gain here? High frequency gain will be, this will be simply src. This will be 2 src. So src upon 2 src, 1 by 2. So high frequency gain is actually 1 by 2. So the gain will be 20 log r by 2. Now it depends whether r is greater than 2 or not. If r is greater than 2, this point will lie above the 0 dB axis. Otherwise it will lie below the 0 dB axis. What about the phase? So for the phase, right, first I will encounter a 0, then I will encounter a pole. So what is the gain at s equal to 0? Gain at s equal to 0 is plus r. So it is providing a phase shift of 0 degree. So initially the phase shift will be 0, then it is providing a then first of all I am encountering a 0, right, 1 by rc. So I will encounter the effect of 0 first. So now this is bit tricky. Now this part is bit tricky. Okay, listen to me carefully. So I am encountering a 0. Where is the 0? 0 is 1 by rc. So 10 times before this 1 by rc, that is 1 by 10 rc, and 10 times after this rc, that is 10 by rc, the effect of 0 will be there. And where is the pole? Sorry, what I am doing, I will encounter the pole first, right? So what is the pole? Pole is 1 by 2 rc. Now 10 times before this pole, that is 1 by 20 rc. I think previously I had made a mistake somewhere here. Okay, sorry, I made a rookie mistake here. This is 1 by 2 rc, right? So 10 times before this will be 1 by 20 rc. What am I doing? कहाँ मर गया भाई, क्या हो गया? Okay, हो जाता है, हिल जाता है कभी दिमाग. Okay, this will be 1 by 20 rc. I'm so extremely sorry for this mistake. 1 by 20 rc, and this will be 10. This will be 5 rc. Okay, पता नहीं क्या सोच रहा था. This will be 5. Sorry, not 5 rc. Sorry, 5 by rc. 5 by rc. क्या कर रहा हूँ मैं? यूनिट से गलत कर रहा हूँ. Okay, 5 by rc. Okay, so I hope that is clear. हाँ, okay. So here, right, 10 times before and 10 times after, this will be 5 by rc. Now the effect of pole will remain in this interval. Effect of 0 will remain in this interval. I am observing I have a common interval. What is that common interval? The common interval is from 1 by 10 rc and 5 by rc. From 1 by 10 rc to 5 by rc, right, effect of both pole and 0 is there. If effect of both pole and 0 is there, then basically overall slope will be 0 degree per decade. Why? Because 0 will provide plus 45 degree per decade, pole is providing minus 45 degree per decade. So overall the slope will be 0 degree per decade. But before 1 by 10 rc, who is present? Pole is present. So before 1 by 10 rc, the effect of pole will be there, that is minus 45 degree per decade. So before 1 by 10 rc, okay, that is 1 from 1 by 20 RC, the effect of pole will be there, right? Okay, and at from 1 by 10 RC, 0 also will come into action. So overall slope will become 0 now, and it will remain 0 till 1 by, sorry, it will remain 0 till 5 by RC. And after this, again, what is left? So pole is gone. So after 5 by RC, pole is gone. 0 is left. 0 is left, right? So till the effect of 0 will be till 10 by RC. So 0 is still left, right? So the slope will increase. Okay, till 10 by RC. Then this value also will go down to 0. Now how can I say that this will end at 0 only and this will start at 0? This will start at 0 because start from 0 degrees, because at s equal to 0 the gain is plus r, which provides a phase shift of 0 degrees. At s equal to infinity, what is the transfer function? S equal to infinity transfer function is r by 2. Again it provides a phase shift of 0 degrees. So I will start at 0, I will end at 0. What about these points? What will be this point? So here what is the slope? Here the slope is minus 45 degree per decade. Here the slope is 0 degree per decade. Here the slope is plus 45 degree per decade. Okay. So what will be the value over here? How do I find it out? So I actually have not crossed a decade here, right? Basically I have crossed twice the length. So this you can calculate. This I am leaving it up to you. What is the value here? This is the homework for you. Okay, calculate this value, whatever is the value here. Okay. So yeah, I hope that is clear. I hope the phase plot is clear. Now let's do the circuit D. So in the circuit D, again let's do with intuition. So here, right, what is the order of circuit? Order of circuit, again, right now I see I have two capacitors, but how many independent energy storing elements I have? So if I provide a current IC1 in this capacitor, is the other current on the capacitor, can we determine the other current? Yes. Is it can you determine it? Is it known to us? Yes, it is simply II minus IC1. II is known to us, IC1 is also known to us. So the current is fixed. If I fix the current across one of the capacitor, the other current is fixed. That means we have actually only one independent energy storing element. If I fix the current here, if I choose the initial value of this current across this capacitor C1, then this current is automatically fixed. So independently I can only set one initial condition. So that's why I have only one independent energy storing element. So here number of independent energy storing element will be 1. Okay. So order is 1. So again I will get an exponential response. For a step input, I will get an exponential response. Now what is the time constant? What is the time constant of the circuit? Okay, the time constant of the circuit will be, right, R equivalent into C equivalent. Okay, so I have to deactivate the current source. So if I deactivate the current source, then if I find out the C equivalent, right, now I will find out the C equivalent because I have two capacitors and a single resistor. So R equivalent will be R only. So what is the C equivalent? So I observe that the C equivalent, right, whatever is the current through here, same current is flowing through the capacitor because here current is 0. So basically these two are in series. So I know when two capacitors are in series, the formula is C1 C2 upon C1 plus C2, that is C by 2, R C by 2. So now the time constant is R C by 2. Okay, now let's do the step response. Okay, let's do the step response. What is the step response basically? So for the step response, it will be simple only. So if, let's do this intuitively. If I have a 1 ampere of current here, right? If I have a 1 ampere of current, initially assumption is both of them are uncharged, so both of them will provide zero impedance. So this will behave totally as a short circuit. This will still provide a impedance of R. So whole of the current will flow through this 1 ampere. Sorry, whole of the current will flow through this capacitor. Now what is happening? Current is finite. So Vc0 minus will be equals to Vc0 plus. So this will hold. This will still be at 0 volts. Now what is happening at infinity? At infinity, as if both of them will behave as open circuit. If both of them behave as open circuit, right, this will provide high impedance, this will provide high impedance. Infinity plus R is infinity, correct? So it does not matter whatever the value of R, this whole thing can be replaced with a capacitor of high impedance, right? This R is negligible. A very high impedance in series with a small impedance is basically high, the high impedance will be dominating, right? So this C will be dominating. So the circuit can be replaced with 2C in parallel. Circuit can be replaced with two capacitors in parallel, and a constant current source is incoming. So both of them, the value of capacitance is C. So both of them are providing equal impedance. So current also will be divided half and half. Now can you replace your capacitor with simply open circuit? If you replace your capacitor with simply open circuit, you will say here 1 ampere of current is coming because the current source will push some current, right, 1 ampere, and here you are saying 0 ampere because they are open circuit. KCL is violating. So what went wrong here? So I told you, right, whatever you know that at t equal to infinity you make the capacitor to be open circuit, you know it wrong. Okay, in this case it will not be valid because at t equal to infinity current does not go to 0, it is some finite current. If it is some finite current, what will happen? My IC is C dVc by dt. In this particular case the current is half, so it will be half equal to C dVc by dt. So my voltage across the capacitor will linearly charge 1 by 2 Ct. It will linearly increase like a ramp function. So it will behave like a ramp. Initially there will be some exponential charging of the capacitors. Then after a certain point it will just behave like a ramp function. Okay, it will not behave as a open circuit. Okay, so the graph, I will show you the graph basically. So let me draw the circuit at t equal to 0. T equal to 0, both of them will be short circuit. So this will be 1 ampere. So all of the current will flow through there, 1 ampere. At t equal to 0, right? So what is the voltage at t equal to 0? Because there is no like this is short circuit, so voltage is t equal to 0 is, so basically here your Vc of 0 minus will be equals to 0 will be equals to Vc of 0 plus, because your IC is finite. So this will hold, but your VO of minus, right, V of plus will be what? It will be simply 0 volt because it is directly across the capacitor, it is 0 volt. And what is the current? IO of 0 plus also is 0 ampere only because all of the current is flowing through here. Now at steady state what will happen, right? If I draw the circuit at infinity, like at very high time, after a long time, I cannot say infinity, right? I cannot say infinity, I can say after very long time, this will provide high impedance, one by Cs and 1 by Cs, right? So both of them provide high impedance, correct? So both of them provide high impedance. The circuit can be drawn like this. I have a 1 ampere current here, and both of them are high impedance. Okay, so both of them are providing a impedance of 1 by cs 1 by cs. So current will be 1 by 2 and 1 by 2 ampere. Okay, so IC of or IO of infinity is half, IO of t is half ampere, t is tending towards, like t is infinity basically. Okay, and your what is your v of t? V of t will be simply, remember this drop does not matter actually, although this drop is there, r by 2. V of t will be basically this current is fixed, r by 2 plus vc of t, right? Vc of t is, it is always linearly increasing, so it will keep on linearly increasing. That is basically your 1 by 2. As I have told you already, the current is fixed, right? IC is fixed. So what will be VC? VC will be integration of IC upon IC of t dt upon c. Okay, this will be IC of t 1 by 2, so 1 by 2 c into t, right? So this will be basically 1 by 2 c into t. That will be your v of t. So at when t is very high, right? When t is very high, roughly this is basically 1 by 2 c t. Okay, so roughly your plots, your current will be, initially your current was 0, right? Then it will exponentially charge after 4 tau to half. Because after that what happens? Current becomes constant. As soon as current becomes constant, your voltage will linearly increase. So initially your voltage was 0, then it was slowly increasing, and capacitor voltage was also there. So I don't know what kind of function this will be, I exactly don't know, but I know after 4 tau definitely it will be something linear. Okay, it will be something like this. So here it will be non-linear, after 4 tau it will be linear. So here, right, in this duration it will be non-linear. I exactly cannot plot the voltage because it is like current is also exponential and your voltage is also exponential, I cannot plot it, but after this it will be linear, and the slope will be 1 by 2c. This will be the slope after 4 tau. Okay, so this will, like, what is the equation of the current? Equation of current is very simple, is 1 by 2 of t, 1 minus e raised to power minus t upon tau. What is the tau here? Into u of t, tau RC by 2. Okay, V of t, V of t will be what? V of t will be like when t is much larger, right? T is much greater than tau. I am assuming t is much greater than tau. The V of t will roughly be equals to t by 2 RC. That's it. Initially it will be some non-linear function. I am neglecting that. You can take it, okay, but I am neglecting that non-linear function. If tau is very greater than, t is very greater than tau, V of t will be simply t upon 2c. That is the linear function. Okay, now let's plot the impulse response. What will be the impulse response? Impulse response actually will be bit easier side than the step response. So impulse response at t equal to 0 minus, these will provide 0 voltage. Now at t equal to 0, this is short circuit, this is short circuit, all of the current will flow through here. So this will get instantly, the voltage will not remain at 0, it will instantly change to 1 by c. This will instantly change to 1 by c. Then this current source will go away, and then this will behave as a source free RC network. So this will discharge slowly, and at steady state what will happen? This capacitor will charge a bit, right? Steady state energy will be totally gone. current will be 0 across this resistor and there is no change across the capacitor. So this current is 0, okay, this current is 0, right, and this will totally discharge. I am just thinking, will this voltage remain at some volts or it will totally discharge? That is interesting, because this will discharge and this capacitor will charge. At certain condition, what will happen, whatever charge is leaving, right, same charge is coming in here, right? So at a certain condition, this point potential and this point potential will be same. At that point there will be no current, and that will be the steady state condition. Okay, that will be the steady state condition. So it's not like it will totally discharge to 0 volts, it will hold some voltage, because this point, like what is the steady state condition? Steady state condition is the condition at which the current goes to 0. There is no change in voltage, because IC is equal to C dVc by dt. So when current goes to 0, there is no change in this voltage. That can happen if the potential between these 2 points are same, then there will be no current. That we will solve using charge conservation. Okay, so I hope that is clear, the intuition part is clear. Now let's draw the circuit at t equal to, like, my Vc of 0 minus equals to 0 equals to Vc of 0 plus. Okay, so here what I can say is, just give me a second, I'm drinking too much water. Now this will not be equal actually, because infinite current is flowing, right, because my IC, remember I am talking about, let me name this as Vc1, okay, let me name this as C1 and let me name this as C2, although they are equal, but for now, so Vc1 of 0 minus Vc1 of 0 plus will not be same, but Vc2 of 0 minus and Vc2 of 0 plus will be same. Why? Because there the current is 0, right? All of the impulse current is flowing through here, right, through this capacitor. None of the current is flowing through here, right? So I can assume this condition to hold, this condition will not hold, because your IC1 of 0 will not be finite. Okay, so if I draw the circuit at t equal to 0, at t equal to 0, if I draw the circuit, okay, this will behave as a short circuit, this will behave as a short circuit, so whole of the current delta t will flow through here. So what will be my Vc1 of 0 plus, Vc1 of 0 plus will be simply integration of delta t of dt upon C, right, upon C1, that is C only, so it will be 1 by C, okay, that is my Vc1 of 0 plus, that is same as my Vo of 0 plus, because Vc1 is same as Vo of 0 plus, right, it is directly connected across my output. What about the IO of 0? IO of 0 is 0 ampere only, okay, no current is flowing through here, all of the current will flow through here. What is IO of 0 plus? For that I need to draw the circuit. So at IO of 0 plus, this, right, supply will go away, this supply will not be there. This will still be short circuit, because this voltage will not change, because this will still hold, but this will be replaced with a voltage source of value 1 by C. Okay, of value 1 by C. So what will be the current IO? Remember, current will flow from this, because this is lower potential, So this current, right, is along the reference direction of current, so IO will not be negative. What is the value of IO? So it will be simply IO will be equals to simply voltage upon the resistance R, because this is providing 0 volts, right, 0 volt, it is short circuit, right. So my IO of 0 plus, IO of 0 plus is simply 1 by RC, and my VO of 0 plus is simply the voltage across the capacitor, that is 1 by C, that is what we have derived already. Yeah, that is what we have derived already. Okay, now what will happen? So basically this, right, capacitor is like some charge is going out and the same charge is going into this capacitor. So if the charges are same, I can apply the conservation of charge property. Whatever charge is going in, coming out of the capacitor, same charge is coming in. So whatever was the initial charge, final charge also will be same. Initial will be equals to charge final. What is the initial charge? Charge is Q equals to CB, right? So at t equal to infinity, I can draw the circuit at t equal to infinity. This will have some potential Vc1, this will have some potential Vc2, because this capacitor was discharging, so here voltage was reducing, but this capacitor was charging because current is incoming to the positive terminal. So one was discharging, one was charging. So at a certain point, what will happen? Steady state will reach, because this current will go to 0. Why this current will go to 0? Because this one potential and this one potential will be same. Basically at steady state, at t equal to infinity, your Vc1 will be equals to Vct, because your current IC has to go to 0. As the current across the resistor will be 0, there is no drop, as if these two are in parallel. Okay. So from this I get a condition, that is Vc1 will be equals to Vc2, that let me name this as V. Okay. So what is the initial charge? Initial charge is Q equal to C into V. Initially C is C1, C1 into V basically. What is the voltage across C1? 1 by C equals to, that is the total initial charge. What is the final charge? Final charge will be, this has a potential of Vc1, that is V only, and its capacitance is C. So C into V plus additional charge I have here, right? It has also voltage of V and capacitance of C, so C into V. So that is the total charge. So from here I get the value of V, that is 1 by 2C. So ultimately at t equals to infinity, it settles to 1 by 2C volts. Okay. So how will the graph look? So at t equal to 0, what was the VO? T equal to 0, the VO was 1 by C. And at t equal to infinity, the voltage is 1 by 2C. So the graph will look something like this. It will settle at 4 tau at 1 by 2C. Okay. At t equal to now current, what is the current? At t equal to 0, the current is actually 1 by 0 plus current is 1 by RC. At 0 it is exactly 0, 0 plus it is 1 by RC, right? Now it is in the same direction, it is not in the opposite direction, so current will be positive, and it is 1 by RC and it is going towards 0. In photo time. Okay. So you have the current graph is clear. What is tau? Tau here is RC by 2. How are the graphs looking? So here the graph will be I of t will be one by RC e raised to power minus t upon tau. Okay. And here it is u of t, and here it will be, so here, right, I will directly not be able to write the voltage. I will use the formula. What is the formula? The formula was V of t is V of infinity. What is V of infinity? It is 1 by 2c plus V of 0 plus, that is 1 by c, minus V of infinity 1 by 2c into e raised to power minus t upon tau. So this will be 1 by 2c minus minus 1 by 2c, sorry, plus 1 by 2c only. So 1 by 2c if I take common, this will be 1 plus e raised to power minus t upon tau into e of t. Okay, so that is what my V of t is equals to. Okay, so what about the transfer function, current transfer function, right? So for the current transfer function, current gain transfer function, what I can do, what is the pole? Pole is basically same, right? Negative of inverse of time constant. Pole will not change. So this will be minus of 1 by RC by 2, that is 2 by RC. Okay, so my omega p will be 2 by RC. What about the 0? Do I have a 0? So for 0, right, this current must go to 0. So when does this current goes to 0? At s equal to infinity. At s equal to infinity, this current will go to 0. So it is not a finite 0. So we don't have any zeros. So at s equal to infinity, IO of s will go to 0, but that is not finite. So not a finite 0. Okay. Any other 0? Can I find any other 0? No. There is no other possibility where the current can go to 0. That is the only possibility. Okay. So what is the DC gain? DC gain is simply half, right? DC gain is simply half because this will be replaced with 1 by CS. So basically the circuit, right? This will be replaced with 1 by CS. This will be replaced with 1 by CS. And if S is tending to 0, right, 1 by CS would tend to infinity. So this R, right, I can neglect the R. The circuit will be replaced with simple a parallel combination of 1 by CS and 1 by CS. Okay. One by CS and 1 by CS. So this is the circuit at S equal to 0. So current will get divided. So basically current division will happen. That is my IO of S. So my H of infinity, right? H of infinity will be the ratio of IO of S over I of S, where my S limit as S tends to infinity. Okay, so this will be 1 by 2. Okay, this will be 1 by 2. So high frequency, so DC gain will be half. Okay, so my transfer function, right, high frequency gain is 0 basically, high frequency H of infinity, right? If I put H of infinity, if I replace the circuit, it will simply be replaced with a short circuit, right, the first capacitor, because it is infinity. So this will be replaced with a short circuit. So all of the current will flow through here. So basically my IO of S will be 0. So H of infinity also will be 0. So my transfer function, right, basically it will be H of S. So my A, right, from here I get my A is half. H of S will be A into A by S plus, sorry, 1 plus SRC by 2. Okay, so A is half 1 plus SRC divided by 2. Okay, Okay, so that is what my h of s is equals to. So can we do the Bode plot? Yes, you can. Like, that is my expectation. I hope you can do the Bode plot. I hope that is not that difficult, right, to do the Bode plot. Okay, so let me do the Bode plot. So at infinity, sorry, at s equal to 0, the gain is half, which is less than 1. So I will start off with below the 0 dB axis. Then I encounter a pole at s equal to 2 by RC, or omega equal to 2 by RC. Due to that pole, the gain will further reduce. I will encounter a slope of minus 45 degree per decade. Okay, so this will be minus 20 of log of 2. This will be minus dB per decade. Okay, so that is the value basically. What about the Bode phase plot? So I only have a pole, and at s equal to 0, it is the gain is plus half, so there is no phase difference. So phase at s equal to 0 will be 0. So initially I will have 0, then I will encounter a pole at 2 by RC, right? So 10 times before it, so omega p is 2 by RC. So 10 times before, that is 1 by 5 RC, I will encounter the effect of pole, that is minus 45 degree per decade, and this will go on till 20 by RC. Okay, 1 by 5 RC, 20 by RC. Okay, so that is the case over here. So what will be the phase at infinity? It will be minus 90, right? If you put here, so what is your h of j omega? It is 1 by 2 upon 1 plus j omega, right, RC by 2. So at omega, if omega tending to infinity, this will go away. So it will be like only j term is there, right? J will go at the top, that is minus j angle is minus 90. So that's why the angle is minus 90 degrees at infinity, and this slope is minus 45 degree per decade. Okay, okay, trans resistance. Now this is interesting, actually will be kind of interesting here, right? The transfer function is this, and the circuit diagram is, what is the circuit diagram? What is the circuit diagram? Circuit diagram. Here is circuit. Okay. So I know this was my transfer function for the current IO of S upon I of S. Now I want to find out the voltage transfer function, right? From here, what I can see, that my VO of S equals to IO of S into one by CS. Okay. So I will replace here, right? So I will replace VO IO of S into RCS plus 1 upon CS divided by II of S. So this will be equals to this value upon into this value, right? So what is happening over here? CS will still stay there actually. So it will become like a second order transfer function. So current gain is first order because in terms of current the circuit was first order, but as I am doing the voltage transfer function is different, right? So always you should ask whether you are discussing about the current or voltage. For voltage this becomes a second order circuit. Okay, if you are measuring the voltage it becomes a second order circuit. So this becomes 1/2 SC, because if you remember the step response of the voltage, right, it was linear function, that is the reason. 1 plus RCS. So if I multiply here by 2, right, this 2 can go inside actually, or does it need to go in? No, let it be there. Okay, so here, right, so what will be the so initially, right, at s equal to 0 I encountered a pole, so I will start off from minus infinity. No. At s equal to 0 I am encountering a pole, and at s equal to 0 what is the gain? What is the gain? What is the DC gain? DC gain is infinity here. So I will start off from like 20 log of infinity is infinity. So I will start off from plus infinity. So somewhere my graph will start off from here. And of course at s equal to 0 I have a pole, so that's why the slope here is minus 20 dB per decade. Then what happens is, which one will I encounter first? So my h of s, right, h of s equals to this will be, just give me 1 second now. This will be basically h of j omega. What is h of j omega? It's 1/2 c j omega into 1 plus j omega rc upon 1 plus j omega rc by 2. So what is my pole over here? Pole is 2 by rc and my 0 is 1 by rc. So I encounter a 0 first, then I encounter a pole. So initially the slope was minus 20. As I am encountering a 0, so it will provide a slope of plus 20, but already I had minus 20. So overall the slope will be plus 0 dB per decade. So there will be no change in the slope. I mean there will be, like, the slope will be 0, so there will be no change in the magnitude. Then after this I encounter a pole 2 by rc. So again it will provide a additional slope of minus 20 dB per decade, and it will keep on reducing. After this there is no change. Okay, what about the phase? Now the phase will be interesting. So at omega equal to 0, right, this term will be dominating, so the phase will be minus 90. So initially, because this will go at the top minus j, this will be 0, this will be 0, this will be 0, this will be 0, this term is dominating, that is minus j, right? So the phase will be minus of 90 at omega equal to 0. Then, right, again that thing will come, right? What thing will come? That common factor wala thing. So here the slope is minus 90. Okay, then what happens? The effect of pole and 0, right? So omega z is 1 by rc, whose 10 times before this 10 by RC, and 10 times after this 10 by 10, sorry, 1 by 10 RC and 10 by RC, the effect will be there, that is plus 45 degree per decade, and omega P is 2 by RC. So 10 times before this, that is 1 by 5 RC, and 10 times after this, that is 20 by RC, the effect will be there. So what is the common region? Common region is from 1 by 5 RC, sorry, yeah, from 1 by 5 RC till 10 by RC. So 1 by 5 RC till 10 by RC, the overall phase shift will be 0, because both the effect of 0 and pole will be there. Okay, so initially at 1 by 10 RC, the effect of 0 will start off, so it will provide a phase shift of plus 45 degree per decade. Okay, plus 45 degree per decade. Then what happened at 5 by RC, sorry, at 1 by 5 RC, the effect of pole is also coming, so overall the phase shift will be 0, because plus 45 minus 45, 0 degree per decade. So this will remain at this will remain constant till 10 by RC. Okay, after this the effect of 0 goes away, so that was providing a plus 45 degree per decade, so only the pole will remain, effect of pole will remain. So after this it will be minus 45 degree per decade, this will be 20 by RC, and after this automatically the effect will go away, and this will end at actually 90 degrees. Why this will end at 90 degrees? Why this will end at 90 degrees? Because very simple, right? What is the phase shift? What is the gain at infinity? What is the gain at infinity? At gain at infinity, like these will get simply cancelled, right? J omega will get cancelled. Okay, what is the gain at infinity? Gain at infinity is actually 0, it is going towards 0, so actually it should end towards 0 only. Okay, so we are kind of wrong, so it will not actually okay, it will not end here, because at infinity, right, what is happening to the transfer function at infinity? At infinity it is 0, infinity it is 0, so we are kind of wrong here. So the graph, right, will look something like this, but it should not go beyond plus 45 degree per decade, so it should pass, then only it will pass, right? Okay, no, it should be minus 90 only. Infinity, what is happening? This, right, this, both of them will not provide any phase shift. This effect is also gone. So if I just write the angle of h of s, right, angle of h of s, so this will be minus 90 plus tan inverse omega RC minus tan inverse omega RC by 2. Okay, so if omega goes to infinity, automatically these are gone. Okay, the angle will be still minus 90, yes, because this will always be there, right? This constant term will always be there. So basically I moved, how much I moved? Double, right? Double. Here also I moved double. So whatever angle I got reduced, the same angle will be increased over here. So ultimately I will end at minus 90. The ending point will be, and ending and starting point will be minus 90 only. Okay, so your task is what? Your task is finding out this value. I hope you can do it. Border plots, if you know, you will be able to do it. Okay. So let's solve the next one, that is this circuit, right? E circuit. So here, now this seems like a bit complex, but the analysis will be same, like just like the previous one. First of all, how many independent energy storing elements are there? So if I assume here a current, right, IC1, So here the current will be fixed. So its energy is fixed, right? So initial condition is fixed. So basically what is happening, if I assume a current here, this current is fixed, IO is fixed, right? So in terms of current, it is a first order circuit, because I can only set the initial value of only one of the energy storing element. So there is only one independent energy storing element in terms of current. Remember, in terms of current. So it is a, I'm talking about the current gain transfer function. Okay, I'm not talking about the voltage transfer function, I'm talking about the current gain transfer function. So in terms of current as well, here in the previous one I forgot to write that down, that in terms of current it's a first order circuit. Where did it go? Okay, yeah, in terms of current. Okay, let's now move on to the circuit E. Okay, how do I find out C equivalent, right? C and R equivalent. So my time constant, it's a first order circuit, so time constant will be R equivalent into C equivalent. Okay, so of course I have to first of all nullify the independent energy sources, that is current. If I nullify it, what do I observe? If I observe that if I have some current here, right, I of t, that same current will flow through this circuit. So basically my resistors R1 and R2 are in series, and C1 and C2 are also in series. So basically R equivalent would be R1 plus R2 into C1 parallel C2. Okay, because it is basically C1 C2 into divided by C1 plus C2, that is why that is what C1 parallel with C2. Okay, that is what my time constant is. Okay, now what will be my initial and final conditions for step response? For step response it will be something similar. Okay, let's understand this intuitively. Initially both of the capacitors do not have any voltages, right? At t equal to 0, this will behave as short circuit, this will behave as short circuit because voltage is 0. This is 1 ampere, so current will get divided in terms of the ratios of the resistor. I don't care, but that current will be finite, that current will not be infinite. At t equal to infinity, what is happening? This will provide high impedance, this will provide high impedance, because they want to reach open circuit, steady state condition, but actually they will never be able to reach open circuit, because if both of them provide high impedance, the current, like these resistors can be neglected, the currents will get divided depending on the values of C1 and C2. Okay, depending on the values of C1 and C2. Okay, so there will be again a non-zero current. Current will not be zero, it will be a finite non-zero current. If current is constant, because the division will be depending on the value of the capacitance, that will not change anymore, there will be some constant value. So the current also, the voltage also will linearly rise, ramp function. So just like the previous case, previous circuit, this circuit also will be almost similar, just the time constant will change and the current values will change. You will see current division values will change. You can compare the previous circuit and this circuit. Okay, rest roughly the graph will be same. Okay, so here my, what is the condition? Let me write this as VC1. So VC1 of 0 minus equals to 0 volts equals to VC2 of 0 minus, right? Sorry, VC1 of 0 minus, because it will hold, this condition will hold because my IC1 of 0 is finite and my VC 2, sorry, this will be 0 plus, right? VC2 of 0 minus will be 0 volt, which will be same as VC2 of 0 plus. Okay, so both will be same. So here, just give me 1 second. What is the current, right? So what is the IC2 current? IC2 current, if I draw the circuit at t equal to 0 plus or t equal to 0, this will be 1 ampere, this will behave as short circuit. Okay, so the current IO will just be by the current division rule, that is R1, like 1 into R1 divided by R1 plus R2, right, which is finite basically, which is finite, right, which is not infinite, so voltage will not change. This will be 0, IC of 0, this is at t equal to 0. Okay, so this is the finite current. Now at steady state, like what is the voltage then? VO of 0, so VO of t, right, is equals to simply IC2 into R2 plus VC2. Okay, so IC2 will be IC2 is this R1 divided by R2 by R1, so it will be R1 plus R2, R1 R2 divided by R1 plus R2 plus VC of 0, right. So I'm writing the voltage expression at t equal to 0 plus, so t equal to 0 plus VC of 0 will be 0, right. So my VO of 0 plus will be R1 plus R2 divided by R1 plus R2. Okay, this is what your VO of 0 plus will be equals to. Okay, so that is done. Now right, what we can do, we can draw the circuit at infinity. At infinity, both the capacitors will provide very high impedance, so the resistors can be neglected because they will provide high impedance. We can see this in the DC gain as well. You will see only capacitors are dominating. In series, higher impedance will be dominating, so resistors can be neglected. So the division of current will happen with respect to capacitance. So what is the impedance provided by the capacitance? It is 1 by C1 of S, right. So my current, right, IC2 of t will simply be 1 into the inverse relation, because how much impedance this provides? This provides a impedance of 1 by, so this is the circuit at after long time. Okay, so this will provide a impedance of 1 by C2 of S, this will provide a impedance of 1 by C1 of S, so it's inverse relationship, right. So now the current will be directly proportional. How? So 1 into the opposite impedance. What is the opposite impedance? It is 1 by C1 of S divided by the sum of the impedance 1 by C1 of S plus 1 by C2 of S. So if you see, it is directly proportional to C2, so it will come out to be C2 upon C1 plus C2. Okay, this is what your IC2 is same as IO, because IO and IC2 are same only, right. So this is at the steady state. Okay, at steady state, this is the current. Okay, what about the voltage? So voltage, right, again this will be dominating, this drop will be dominating, this will behave as a short circuit. Okay, voltage will be linearly increasing, so VO will be roughly equals to VC2 of t, that will be basically current is constant, C dVc by dt is IC, so it will be integration of IC2 upon C2, right. So integration will be C2 upon C1 plus C2, so it will be 1 upon C1 plus C2. I'm just thinking, is it correct? Yeah, T into 1 upon C1 plus C2. Yeah, T into 1 upon C1 plus C2. So this is the voltage basically. Is this correct? Should be correct. current is this. Yeah, CC will get cancelled. C2, yeah, should be correct. CdVC by dt, yeah, it is correct. So, so roughly, right, how will the voltage and current waveform be? So initially my current was, now whether initially my current was R2 by, sorry, R1 by R2, R1 plus R2. So it is R1 R1 divided by R1 plus R2, okay, R1 divided by R1 plus R2, and then my current became C2 divided by C1 plus C2. Now it depends on like whether which one is higher. I don't know which one is higher, right? So assumption is I'm assuming, assume that initially R1 divided by R1 by R2 is greater than C2 divided by C1 plus C2. So what I can do, I can divide by R1 and C2 on both sides. So this will be 1 divided by 1 plus R2 by R1 greater than 1 divided by 1 plus C1 by C2. So from this I can get a conclusion that this value is higher than this value. Like this is my assumption, okay. So this value is higher than this value. That means this value has to be lower than this. This value has to be lower than this. The denominator must be lower, then only overall this function will be higher. So basically my R2 by R1 must be greater, sorry, must be less than C1 by C2. So C2 R2 must be less than C1 R1, okay. That is the condition basically that we have chosen. So as I am telling that this value will be, initial value will be higher than the final value, so it will somewhat discharge, and then it will remain constant after what time? 4 tau time. What is tau here? Tau, we have already discussed what is tau. R1 plus R2, C1 parallel with C2. Okay, so what will be the current expression IO of t? So this value, right, this value is this value here is C2 divided by C1 plus C2. So it will be I C2 divided by C1 plus C2 plus 0 R1 divided by R1 plus R2, like this will be the expression, okay. C2 divided by C1 plus C2. Now you can solve. This will be the expression T upon tau. This will be the current expression. Now what about the voltage expression? What will be the voltage expression? So the voltage expression will be initially, right, initially what is happening to the current is actually reducing, right, current is reducing, but still the voltage shall increase because this capacitor will charge initially. So slightly this, like this will be non-linear initially, okay, then this will charge and this will keep on linearly increasing, okay. So it will be linear after 4 tau time because the voltage is a linear function. So till 4 tau it will be some non-linear function, then after 4 tau, right, somewhere around here, it will become linear function, okay. So I hope it is clear. It will become linear function. So roughly, right, your V of t roughly will be equals to 1 by C1 plus C2 into T into E of T. Of course, here also there is E of T multiplied. What will happen to the impulse response? So, impulse response, what I feel is that in impulse response, at t equal to 0, what will happen? Again, the currents will get divided, impulse current will get divided, right? Because both of them will behave as short circuit, so current will get divided according to the resistance value. So your impulse current is getting divided, so some infinite current will flow with like infinity into R2 by R1 plus R2, infinity into R1 divided by R1 plus R2. It is still infinity, so still infinite current will flow. So your condition will not hold, your capacitor will not hold its initial value. There will be some sudden jump or sudden decrement in the voltage. There will be sudden jump, actually current will be incoming. Okay, there will be sudden jump of voltage, so voltage will suddenly increase. Now voltage suddenly increases, after that this current source is gone. Then what will happen? There will be some charging discharging between the capacitors. Now it depends really on the value, right? It depends on the value that which capacitor will charge and which capacitor will discharge. But one thing is for sure, I know whatever charge will come out or come in to this C1, same charge will come out or come into this C2. So again they are in series because this current source is deactivated. Again, what will be the steady state condition? Because charges, right, same charges flowing throughout the circuit, charges charges conserved. Again I can use the charge conservation of charge principle. So initial charge will be equals to final charge. From that I can identify the voltage V, because V of infinity here and here will be same, because at infinity the current will become 0 through this resistor, so there will be no drop. So this point potential and this point potential will become same, both these potentials will be same basically. Okay, so that is the intuition. Now let's solve. So again your properties will not hold. Your Vc1 of 0 minus will be 0 volt, which will not be equals to Vc2 of 0 plus. Here as well your Vc1 of 0 plus, Vc2 of 0 minus will be 0 volt, which will not be equals to Vc2 of 0 plus. Okay, these conditions will not be equal basically. So so what I can do is what will happen? So at t equal to 0 I have to draw the circuit, right? At t equal to 0 I have to draw the circuit. So this capacitors will behave as a short circuit, so ultimately the current division will happen with respect to the resistors only. At t equal to 0 I am drawing the circuit at t equal to 0. Okay, so this will behave as short circuit. Okay, so current, right, current division, what will be the current division? So IC1 will be R2 divided by R1 plus R2 into delta of T, and your IC2, this is the current at t equal to 0, right? R1 R1 plus R2. Okay, so that is the current basically, IC2 and IC1. Okay, now remember, okay, it is delta t, right? It is not, it is infinite, it is not finite, infinite. So what is the voltage developed at Vc2 of 0 plus? Vc2 of 0 plus will be simply 1 by C2 into integration of current, right? That is R1 divided by R1 plus R2, right? So integration of IC2 t of dt, correct? So this will be equals to R1 divided by C2 into R1 plus R2. So this is the voltage developed at t equal to 0, okay? And voltage developed at t equal to 0 of Vc1 will be, I don't care actually. No, actually that I care, because that will be required. That will be actually required. Vc1 0 plus will be integration of IC1 of t dt divided by C1. So this will be R2 divided by C1 into R1 plus R2. Okay. Okay. Now, what will be the current, right? So this is the circuit at t equal to 0. At t equal to 0 plus, what will be the circuit? So the voltages are there. Current source will go away because impulse only stays for t equal to 0. It goes away. So at t equal to 0 plus, here the voltage will be so this voltage, right? This voltage will be, let's name this as Vc1 of 0 plus, and this voltage will be Vc2 of 0 plus. Okay, so the current, right, IO, what will be the current direction? So IO is in this direction, so I will assume that this is higher potential because IO is in this direction. So I want my current to flow in this. If this is lower potential, automatically the current will come out to be negative. So from here, the current IO of 0 plus will be Vc1 of 0 plus minus Vc2 of 0 plus divided by R1 plus R2. Okay. Okay. Hectic. This is hectic, right? Okay. So I have to subtract these two values. That's difficult to subtract. C1 R2, C1 R2. Okay, R1 plus R2 anyways will not get cancelled. It's difficult to cancel, right? C will be R1. Okay. Which one is higher, which one is lower? How do I say which one is higher, which one is lower? So few things I have assumed here, right? Initially R1 plus, okay, I have assumed this one is higher. So basically R1 C1 is higher than R2 C2. Okay. R1 C1 is higher than R2 C2. So if I write the expression over here, so this will be okay, R1 plus R2 is anyways in common. I can take R1 plus R2 in common, right? R1 divided by C2 minus, sorry, this is Vc2, right? Vc1 is R2 divided by C1 C1 minus R1 divided by C2, okay, divided by R1 plus R2 is already there. So this will be okay, I have to multiply C1 over here, C2. So this will be R2 C2 minus R1 C1 divided by R1 plus R2 whole square. So what I have assumed? I have assumed that my, okay, this is small, right? So my C1 R1 is higher than R2 C2. So this value is higher according to the previous like assumption that I have taken. So your current, right? Current at 0 plus will come out to be something negative. So if it comes out to be negative, what does that mean? That basically means that this capacitor is discharging and this capacitor is charging. Current is flowing out, so this capacitor is discharging, voltage is reducing, and this voltage is increasing. So what will be the circuit at t equal to infinity? At t equal to infinity, again whatever charge is coming out, same charge is coming in. So we can take the steady state value, because at steady state current will be 0, these two potentials will be same, right? So this potential will be V and V, because current will, then only current will be 0, right? Otherwise current cannot go to 0. This will be V, then only there will be no potential difference across the resistor, so current will be 0. So t equal to infinity, this will be VV. So I will apply the conservation of charge, because whatever charge is coming out, same charge is going in. So I can apply the conservation of charge principle over here. So initially what was the charge? Initially, so Q initial will be equals to Q final. So what was the charge initially? So initially what was the charge? Initially what was the charge? So this is VC1, right? So initially the charge was C1 into VC1 of 0 plus C2 into VC2 of 0 plus. Now finally the charge is C1 into V plus C2 into V. Both voltages are same. So ultimately, right, your V will come out to be C1 into VC1. What is VC1? VC1 is this value, right? VC1 is this R2 by C1. So C1 into VC1 will be R2 by R1 plus R2. So this will be R2 by R1 plus R2, and C2 into VC2. This also will be R1 divided by R1 plus R2. So R1 divided by R1 plus R2. So actually it comes out to be 1. So like incredibly it reaches to half, or not half, sorry. Of course I will have here C1 plus C2. So in like the steady state condition will be same, just like the previous one. Steady state condition will be 1 by C1 plus C2. Okay. What is happening to the current? So initially current was negative, right? Here current is 0. So at t equal to 0, current was impulse current was divided. What was the amplitude of that, or area of that impulse? What was the area of the impulse? Area of the impulse was, if I see, for I'm talking about IC2 because I only care about IC2, that is equals to my I0, that was equals to R1 divided by R1 plus R2. So the area of the impulse here will be R1 divided by R1 plus R2, this area of impulse, right? Okay, let me keep it here. This thing is the area. Okay, then what we can do is then, right, at t equal to 0 plus, the current is negative. It is some finite current that is negative. What is the value of the current? This R2 C2 R1 C1 divided by R1 plus R1 plus R2. So it is something negative here. Then it is going to 0. What time? 4 tau. What is the tau? Tau is R1 plus R2 into C1 parallel with C2. Okay. What is the value of the current here? A value of the current, right, is R2C2 minus R1C1. Automatically this will go negative because your R2C2 is less than R1C1. What about the voltage? So at t equal to 0 minus, the voltage is 0. Suddenly a impulse current came. Due to that impulse current, what will happen? Now remember, right, one thing you must remember, impulse current is coming, right? So initially this was providing 0 voltage. If this was providing 0 voltage, so whole drop will be across R2. What is the drop across R2? That is IC2 into R2. What is IC2? IC2 at t equal to 0 is R1 plus R2, R1 divided by R1 plus R2 into delta of t. So this will be R2 into R1 divided by R1 plus R2 into delta of t. So overall voltage at t equal to 0 will be an impulse R1 R2 divided by R1 plus R2 into delta of t. So here the impulse will be, I will have an impulse exactly at t equal to 0 and its area will be R1 R2 divided by R1 plus R2 into delta of t. Okay, then what is happening? Then I have told you that this is discharging, right? It is discharging. So will the voltage be negative or positive? How will I find out the voltage? Okay, just give me 1 second. So here, right, what is the current at t equal to 0? This is the current, right? That is negative. I have to multiply this with R2 and then I have to add with this initial voltage. Which one will be higher? That is a hectic task. So I don't know whether it will be negative or something. Okay, at infinity what is happening? At infinity this voltage is coming out to be 1 by C1 plus C2, that is something positive. And it is discharging. I have told you that initially current is negative, so it is discharging. It is discharging, right? So this will be plus minus, and anyways this is the discharging. So this will be at higher potential than this potential, right? So automatically VO will be something positive because this is discharging. So this will be at higher potential than this, all these things, right? So VO will be something positive and it is discharging, reaching to 1 by C1 plus C2. So it is anyways, this voltage is anyways, it is subtracting. So this is reducing, this is also reducing, right? But overall this will reduce more. So I think the graph will be somewhat like this. So it will start from here, right, and then it will decay down to this value. So here, right, what was the so I will not be able to exactly comment what is the volt value here. Like you can comment, you can find out, like you already know, right, what will be VO of 0 plus. So your VO of 0 plus simply will be IO of 0 plus into R2 plus VC of 0 plus. You can do this, no problem. Remember this is negative. So overall VC of 0 plus will be anyways higher than this, right? So overall this will be coming something to be positive. So it will start off with something positive. Okay, then it will settle down to V. What was V? We calculated V. V was actually 1 by C1 upon 1 by C1 plus C2. Okay, so that is what my V is equals to. Okay, so this is my 4 tau. So what will be the voltage and current equation? So voltage, right, current equation, IO of t will be some, okay, I will not be able to write. So this value will be some A value. I don't know what is this value, A naught. I don't know what is this initial value. You have to compute the value, but it will be something positive. Okay, so your current equation will be, first of all, there is some impulse that is there. then minus, sorry, not minus, plus, automatically this is negative, right? It is negative automatically, into e raised to power minus t upon tau. Tau I have already said what is tau, into e of t. Okay, what about the voltage? So the voltage will be somewhat similar only. Okay, voltage will be difficult for me to write. Okay, voltage, right? V of t R1 R2 divided by R1 plus R2 into delta of t plus a naught so initial value is a naught, final value is this, right? So it will be something 1 by c1 plus c2, just give me 1 second, this will be 1 by c1 plus c2 plus a naught minus 1 by c1 plus c2 into e raised to power minus t upon tau into e of t. I will just reduce the size because we are not able to fit stuff, right? So it will reduce the size, unfortunately. Yeah, here. So this will be reduced. This will be your voltage expression. Okay, a naught you can obviously calculate, right? I have told you how to calculate a naught. Okay, so what about the current transfer function? So when does my current go to 0? Sorry, what is the pole? Pole is minus 1 by, pole is minus negative of time constant, that is minus 1 by R1 plus R2 into C1 parallel C2. So this will be my omega p, this. Okay, what about the 0? Will my current ever go to 0? At s equal to 0, at s equal to 0, both are providing actually high impedance, so current is not 0. At s equal to infinity, again both are providing some finite impedance, right? R1 R2, again current is not 0, so there is no 0, no 0. What about DC gain? At s equal to 0, if I replace the circuit, again you can see same thing, right? Whatever we discuss at t equal to infinity will happen at DC. So frequency and time, right, domain are the mirror image of each other. So there t equal to infinity will be same as s equal to 0 here. S equal to infinity will be same as t equal to 0 there. Okay, like just a intuition. So at s equal to 0, this will, like, I can neglect the resistance because this drop will be much higher, because this impedance will be much higher, that is 1 by c So let me just delete this actually. So basically what will happen, this will provide 1 by C1 of S, this will provide 1 by C2 of S. So because why? Because if I put S0, this is infinity, this is infinity, right? Both are providing very high impedance. So R2 and R1 I can neglect. Finite plus infinity is infinity. So now from here I can do the current division rule. Again the same thing, right? Same thing, nothing much here. IO of S upon II of S when S tends to 0 is simply equals to current division, that is C2 upon C1 plus C2. So this is the value of A. So my transfer function, right? Transfer function H of S is A because it does not have a 0 plus 1 plus S tau. Okay. So from here I get the value of A. Okay. From here I get the value of A. What about high frequency again? At high frequency, okay, at high frequency I am getting a finite gain. So I should actually get a 0. Okay. Oh, sorry, I missed a point. We have a 0 actually. Sorry, I'm really sorry. This is wrong, right? We have a 0. So what is happening? So I want my current, output current to go to 0. How can I make the output current to go to 0? I can assume this, that somehow if all of the current flows through here, so this must provide lowest impedance. In parallel, lower impedance dominates. Correct? So how can I make this 0? So what we can do is, I can short circuit this in series, right? If I have impedance in series, if this provides 0 impedance, then all of the current will flow through here. How can I short circuit it? So what is the impedance? R1 plus 1 by SC1. So if I make this impedance equal to 0, right? That is the impedance provided by this series combination. If I make this 0, all the current will flow through here. So from here I get the location of my 0, that is minus 1 by R1C1. Okay, I'm sorry, I'm extremely sorry. It has a 0. So my transfer function H of S is A upon 1 plus S R1 C1 divided by 1 plus S of tau. Okay, so we know the value of A. From high frequency gain as well I can verify. High frequency gain as well I can verify this thing. So at high frequency what will happen? At high frequency, this will behave as a short circuit because it is 1 by CS, S is infinity, this will be 0, this will be 0. So at S equal to tending to infinity, this will behave as short circuit, this will behave as short circuit. Okay, so your what will be the current IO of S? Upon II of S. Okay, IO of S upon II of S will be equals to R2, sorry, R1 divided by R1 plus R2. Okay, so can we verify this? So this is H of infinity. So what is H of infinity? H of infinity, if I write the transfer function, it is 1 by 1 plus S R1 C1 divided by 1 plus S tau. So high frequency terms will be remaining. So only the terms coefficient of S will be remaining. So it is A R1 C1 upon 1 plus, sorry, upon tau. Right. So what was A? A was C2 by C1 plus C2. C2 divided by C1 plus C2 into R1 C1 divided by tau. What is tau? Tau is R1 plus R2 into C1 parallel with C2, that is C1 C2 divided by C1 plus C2. So this will get cancelled, C1 plus C2 will get cancelled, okay, C1 plus C2 will get cancelled, C1 will get cancelled, C2 will get cancelled. It becomes R1 by R1 plus R2. So isn't that what we found out over here? So this is how you can verify. If you are in the exam or interview, this is how you can verify whether you have actually solved the transfer function correctly or not. Because you have, like, you had three unknowns here, right? 0, pole and the DC gain, and you have 4 equations. So with 3 equations you found out the unknowns, and with the fourth equation you can cross verify your result. Okay, so I hope that is done now. So we will plot the Bode plot basically. Okay, so what is the Bode plot? Bode plot will be, my assumption is, what is my assumption? My assumption is R2 C2, like I will write the assumption here as well, right? You can take your assumption and your Bode plot will be changed basically. R1 C1 will be greater than R2 C2. So R1 C1 will be greater than R2 C2. Okay, here also R1 C1 is greater than R2 C2. So if R1 C1 is greater than R2 C2, so I can do few analysis, right? What kind of analysis? So what is the high frequency gain? High frequency gain is this, and low frequency gain, zero frequency gain is this, right? And we have already established this, that this value is higher. This is what? This is my high frequency gain. So high frequency gain is higher than the low frequency gain. So according to my condition, right, you can see, you can prove it, right? H of infinity will be higher than H of 0. Okay, so what is the transfer function? Transfer function is A upon 1 plus SRC SR1 C1 upon 1 plus S tau. Okay, 1 plus S tau. Now high frequency gain is higher than the low frequency gain. What does it mean basically? So what will I encounter first? So there are many cases here. I will not solve for all the cases. Okay, in the previous marathons I have already solved for these kind of cases, right? I will not solve it here. So I can see my high frequency gain is higher than low frequency gain. I am encountering a pole and a 0. So let's assume that I encounter a pole first, then a 0. Okay, I encounter a pole first, then a 0. What will happen? So initially I will have DC gain, this will be constant, then I will encounter a pole, and then the 0 will make the slope 0 again. So here I observe that my low frequency gain is higher than the high frequency gain. Will that condition satisfy here? No. So my 0 must be before my pole. My 0 must come before my pole, then only what will happen? If my 0 comes before my pole, initially I have some DC gain, 0 comes, so I will get a slope of plus 20 dB per decade, then I will have a pole that will again bring the slope down to 0 dB per decade. So this will give me the slope of plus 20 dB per decade. This will be the slope of 0 dB per decade. This will be the slope of 0 dB per decade. Okay, so this is the Bode plot actually. Without knowing everything, without knowing these values A, B, A, tau, R1, C1, I can directly say my Bode plot. That's how intuition works. If you have loved this concept, comment down below, like the video. Okay, बोलो भाई मजा आ गया. ठीक है, तो थोड़ा सा मार्केटिंग करते रहना चाहिए. So yeah, that's this basically. So like I will just quickly cross verify. बड़े बड़े बात तो बोल दिया, मैं cross verify कर लेता हूँ. Like it will just be the opposite of the time domain response. If you see in the time domain, my at infinity the value was lower and at 0 the value was higher. So the frequency domain will be just flipped. At infinity the value will be higher, infinity the value will be higher, and at 0 the value will be lower. Okay, so that is what you have to take care of, right? So phase plot, right? Phase plot, I am leaving it up to you as a homework. But you can do it, right? I hope you can do it. So one thing is established, that my 0 will come first, then pole. So my 0 comes first, 0 will come first, then my pole will come. That much is established. And at infinity I am getting a positive gain, at 0 also I am getting a positive gain. So both will provide 0 degree phase shift, right? And the graph roughly will be somewhat like this. Roughly I can draw the graph, somewhat it will be like this. Whatever will be the increase, the same will be the decrease basically. Then the effect of pole will come again here, and then the effect of 0 will go away, and then the effect of pole also will go away. Okay, so this will be the rough graph. Basically it will be symmetrical basically. 10 times after the pole, so this point, these 2 points will be omega z somewhere, yeah, somewhere around here I will have the pole, correct, and this will be the point of what effect of pole will go away, and this will be the point where the effect of 0 will go away, and this will be the point where the effect of 0 will start. And okay, increase, sorry, now this will be the point where the effect of, so this will be omega p here, this will be the point where effect of 0 will go away, because only like the pole slope is there, minus 45 degree per decade, and this will be the point where the effect of pole will start. Okay, so all this I am doing with intuition. So this will be minus 45 degree per decade, this will be plus 45 degree per decade, and this will be 0 degree per decade. It will start from 0, end from 0, because the transfer function, right, is positive in both infinity and s equal to 0. Okay, I hope that is clear. So let's now, okay, I don't want to do it for the translations amplifier. That is up to you. I'm leaving it up to you as a homework. Okay, बहुत tired हो गए भाई, अभी नहीं कर सकते. So leaving it up to you, and I don't feel they might ask, but I don't feel that they will ask you this. Okay, you can do it obviously. So let's now solve the next one. Next one is actually pretty simple. What is the order of the circuit here? Can you tell me what is the order of the circuit? So in terms of current, the order is again first order. Am I correct? Order should be first order, because you will say, sir, I have a single energy storing element, it should be first order. Kind of correct, kind of wrong. If I assume a initial current here IC1, I know the current here is fixed, but I know that order actually is decided not only by capacitor, resistance also should be present. So although the number of independent energy storing element here is 1, but there is no resistance, R is 0. So that actually nullifies the order, that makes the order of the circuit to be 0. Order of circuit is 0 order. 0 order means the behavior will not be transient, sorry, the behavior will not be exponential, the behavior will be just like a step function. It will just follow the input, you will see. So what is the transfer function? What is the transfer function? It is a 0 order circuit. What is the transfer function? Transfer function is very easy, I of s over I of s, right? So basically here what will happen, if I draw the Laplace equivalent, So how will the current get divided? Again, opposite of impedance, so 1 by C1 of S divided by 1 by C1 of S plus 1 by C2 of S, so which is equals to C2 upon C1 plus C2. Okay, so it is basically constant, right? Your output is constant multiple of input. Okay, so you can assume C1 C2 to be anything. You can assume C1 C2 to be C. If I assume that, this will be simply half. Okay, so your output will just follow the input. What will be the unit step response? It's very simple. Intuitively I can say, so initially, right, 1 ampere of current is there and these are uncharged, so both of them will behave as short circuit, but both of them are in parallel, so the current will be divided according to their impedances, because both C2 and C1 are in parallel, there is no resistance, so current will be, if the both of them are equal, it will be just half. And at infinity, what is happening? At infinity, this will behave as open circuit, then also they are providing same kind of impedance, 1 by C1 of S, 1 by C2 of S, then also the current will be divided by half, because this will not go away, so then also the current will be half only, so current will always be half, current will always be half, so your voltage will always linearly increase. Okay, that as that is as simple as that. So initially what will happen, this will behave as short circuit. Okay, so in this case, right, you are kind of lucky because your current is finite actually, although the current gets divided to both of them, current is still finite, so it's not like your property will not hold, your VC of 0 plus and VC of 0 minus will be same. So let me keep them both same capacitance value, and your VC of 0 minus is 0 volts, that is equals to your VC of 0 plus. Okay, so now because why these are equal, IC is finite, so how will I replace them? Like at t equal to 0 they will behave as short circuit only, right? So IC of 0 0 will be 1 by 2. Okay, same, right? IC of infinity also will be 1 by 2, right? IC of infinity also will be 1 by 2. This circuit will basically not change, right? So this will behave as a short circuit, both of them will provide very low impedance, right? So that's why it will get divided according to their capacitance value at t equal to infinity, and sorry, at t equal to 0 and at t equal to after very long time, right? So you cannot simply short circuit them, right? You cannot do this. Okay, what you need to do, yes, you can short circuit them, there is no problem, you can do the short circuit. Oh yeah, short circuit will be there because VC 0 plus and VC 0 minus are same, so your VO of 0 plus will be 0 volts, but here, right, you cannot open circuit them actually, you cannot open circuit, the values will be still C and C, you cannot open circuit because current is not 0, right? You can only open circuit the capacitor when the current is 0. Okay, so this will be 1 ampere, so this will be basically your this will be 1 ampere, so 1 by 2, so your IO of infinity will be what, 1 by 2, and your V of t will be what? After a very long time, it will simply be integration of IC dt upon C. So it will be 1 by C. So it will be basically t by 2C into u of t. Okay. So your graph will be, current will always be constant. Just before t equal to 0, it is 0. It will follow the input half, and your voltage will, before t equal to 0 it is 0, then it will linearly increase. So this slope will be 1 by 2C. Okay, that is the slope over here. I hope you have understood. Okay, so your current, right, I of t will be 1 by 2 u of t. Your voltage V of t will be 1 by 2C into t into u of t. Okay. What will be the impulse response now? Let's do the impulse response. So impulse response is again simple. So initially, before t equal to 0, both of them are providing 0 voltage. At t equal to 0, both will act as short circuit, and I'm assuming that C1 is equal to C2. So this impulse current at t equal to 0 will just get divided, delta by 2, delta by 2. So current is not finite, so Vc1 will not be equal to Vc2. So they will get instantly charged to certain voltage. Okay, so now actually let's not keep them equal, let's keep them unequal. That will be good for us to understand something. Okay, so they will get certainly charged to some voltage. What will be that voltage? That voltage will be C2 upon C1 plus C2 into, sorry, 1 by C1 plus C2. That voltage will be 1 by C1 plus C2 for both of them, right? For both of them, they will actually get charged to same value. I will show you. They will get charged to same value, 1 divided by C1 plus C2. And of course, if they are at same potential and this impulse is gone, so here the current is 0 and they are at same potential, so there is no charge distribution because both of them are at same potential. So they will remain at that potential, that is 1 by C1 plus C2 forever. Unless and until the circuit conditions change, they will remain at that potential. Okay, so I hope that is clear, right? So yeah, that is it. That's the analysis basically. So let me draw the circuit at t equal to 0. At t equal to 0, both of them will behave as short circuit, but both of them will provide low impedance, right? Low impedance, but zero impedance cannot be possible because both of them are providing low impedance, right? So they will be divided, current will be divided like what? Here, right, your Vc1 of 0 minus will be equals to 0 volt, but which is not equals to Vc2 of 0 plus. Your Vc1 of 0 plus, Vc2 of 0 plus 0 minus will be equals to 0 volt. It will not be equals to Vc2 of 0 plus. Why? Due to IC not being finite. IC not being finite. Okay, so IC is not finite here, right? So now what will happen to the current? So to the current, right, the current current will be what? Current will be, so IC2 will be what? IC2 will be basically again 1 by C1 of S upon, sorry, 1 by C2 of S, so yeah, 1 by C1 of S upon 1 by C2 of S plus 1 by C1 of S, which is same as into the input current, that is delta of t, which is same as C2 upon C1 plus C2 into delta of t. Okay, so uh, this is the circuit at t equal to 0 plus 0, right? At t equal to 0 plus, what will be the circuit? So what is the voltage developed? Vc2 of 0 plus. Vc2 of 0 plus will be 1 by C2 into integration of IC2 of dt, which is actually 1 by C1 plus C2, which is same as, so it does not matter whatever the value of C1 and C2 is, they will actually be at the same potential. Vc1 of 0 plus also will be, you can calculate, it will be same as 1 by C1 plus C2. So at t equal to infinity, right, t equal to infinity, how the circuit would look? At t equal to 0 plus, the circuit will look somewhat like this. This will go away. So both of them are same, that is 1 by C1 plus C2, 1 by C1 plus C2. What will happen to the circuit at t equal to infinity? Same, nothing will change. Okay, same, exactly carbon copy. See, this is t equal to 0 plus, t equal to infinity. Okay, nothing will happen because there is no path for discharging, right? Nothing will happen. So Vc of infinity will be C1 plus C2. It will be 0 ampere. Okay, IO of 0 plus also will be simply 0 ampere. Only a impulse current will come because it is simply following the input, right? So your IO, right, at t equal to 0, it will be tilde t by 2. This will remain at 0. Then VO of 0, right? VO of 0, initially, like, we are getting a voltage 1 by C1 plus C2, and this will remain forever. Okay, pardon for my drawing. So here basically if you see, your time constant rate is 0, and that is evident from the graphs. It is not taking any time to settle, it is instantly settling. Now current expression is simply delta of t, sorry, it is actually not by 2, right? It is sorry, it is C2 divided by C1 plus C2. So it will be C2 divided by C1 plus C2 into delta of t. Your voltage is fixed, actually, voltage V of t equals to 1 by C1 plus C2 into E of t. Okay. Now let's discuss about the transfer function. I have already discussed, there is nothing much to discuss. Your transfer function is simply IO of s divided by II of s, that is half. Okay, nothing much to discuss over here, so I should not keep all these pages, these are just a waste of time. let's directly move on to the border plot. Actually this also I should not include. Directly let's move on to the border plot. Border plot is just a constant which is half, so it should be below the 0 dB axis. It will be constant, it will never change. We don't get any pole or 0, it will always be constant. So this will be minus 20, let me keep it somewhere here, minus 20 log of 2. And what will be the phase? Phase is always plus 90, right? Sorry, always plus 0, because it is not changing. It is always positive. It is not changing with frequency, so it will be always 0. Phase will be always 0. Okay. Okay. Trans resistance. Yeah, trans resistance actually is interesting, because if you remember, your output, right, is 1 by C2S. So your VO of S actually is equals to IO of S into divided by C2 of S. Okay. So your I know my IO of S, so I have to find out my VO of S over II of S, that is equals to 1 by C2 of S into IO of S over II of S, that is half. So actually the resistance transfer function, I get a pole at S equal to 0. Okay. So the graph, sorry, really sorry for that. I don't know, I have not had dinner yet, but how did this bug came? Okay, so like if I put S equal to 0, like very low value, right, this will be actually very high gain. This is very high gain, so I will start off with plus infinity. So I will start off somewhere positive, and I am encountering a pole, so always I will start off with minus 20 dB per ticket, and this will always be there. There is no pole 0, so this will always be there, minus 20 dB per ticket. Okay. Can you tell me when is it crossing the 0 dB axis? When my gain will be 1? When is my gain 1, right? What is my h of j omega? H of j omega will be 1 by j 2 omega C2S. So omega, so what is the value of omega at which the gain is 1? Then only it crosses the 0 dB axis. So 1 by 2 omega C2 of S. So basically my omega has to be equals to 1 by 2 C2 of S. So the 0 crossing frequency, right, it will be, sorry, not S, sorry, what am I talking? S is not there, right? What am I talking? S. Okay. It will be 1 by 2 C, sorry, C2 is there, so it is C2, right? C2. 1 by 2 C2. Okay, that is what your unity gain frequency. This is actually called as unity gain frequency, UGF. The frequency at which the gain is 1. Whatever the phase. So the phase, right, it's very simple. I have just encountered a pole, and that pole will always be there because it is a pole at S equal to 0. So what is the angle? It's very simple to plot the angle of this, right? That is minus 90. At any value of omega, it will always provide minus 90. So my phase, right, will always be minus 90. Always be minus 90. So now let's solve like few standard circuits which we already solved actually, right? Just few things we are doing different. Now I am taking the output at a different point. Okay, these things we have already solved. We are taking the output at a different point. So again, the order of the circuit will be 1 here because only a single energy storing element is present. The time constant is same actually. It will be R1, it will be 2R C because both are in series. Okay, because I will just tell you, I will deactivate the energy storing element and I will calculate the R equivalent. Now what will happen with the initial and final conditions? like similar, right? Same things will happen. No difference, no difference. With unit step, this will behave as short circuit. So all of the current, right, like this will get divided half half. Current is finite, so Vc0 will be Vc0 minus will be Vc0 plus. Then slowly this will energize, so this potential will increase, and here I am providing some fixed current, right? So this current will actually reduce. Okay, this potential will increase, so the current across the resistor will slowly reduce, this current will increase, and at steady state this will be open circuit, current will be zero, all of the current will flow through here, and the voltage, right, will be, this is zero drop, so VO voltage will be the voltage across the resistor, that is R. Okay, initially what is the voltage? Zero, because it is the voltage across the capacitor. So I hope I don't need to explain much. So same thing, my Vc of 0 minus will be equals to Vc of 0 plus. Why? Because your current is finite. Okay, current is finite. Now what is the value of the current? Value of the current is simply half. We can draw the circuit at t equal to 0. You can see this will behave as a short circuit, right? So the current will be simply half, right? So from here 1 by 2 current will flow, from here 1 by 2 current will flow, right? So which is finite. So my IO of 0 plus is simply half at t equal to 0 plus my, what is my VO of 0 plus? VO of 0 plus will be 0 volt as proven, right? Current is finite. Infinity, if I draw the circuit, this will behave as a open circuit. Okay, so all the current will flow through here 1 ampere, no current will flow through the outside. So IO of infinity will be 0, VO of infinity, so this drop will be 0, right? Current is 0, so it will be, all of the drop will come up, all of VO of infinity will be same as this voltage, because this drop is 0, so it is, which is simply 1 into R, which is R volt. Okay, so how will the graph look? So initially the current is finite 1 by 2, then it went to 0. What was the tau? Tau was R1 plus R2 into C. This is half. What is the voltage? Voltage initially was 0, then it settled to R. This is 4 tau. This is 4 tau. Okay, so the current waveform will be 1 by 2 e raised to power minus t upon tau e of t v of t will be R into okay, into E of t. Right? I hope it is fine. So these are the graphs. Same for the impulse response. So impulse response, things will be like things will be a bit different. So here my Vc of 0 minus will not be equal to Vc of 0 plus. Why? Because current will get divided delta t by 2, delta t by 2. This will get initially like instantly energized to what voltage? 1 by 2c. Okay, the voltage will instantly change to 1 by 2c. So 0 plus voltage and 0 minus voltage will not be same. Then what will happen? Then this impulse will be gone. Then this 1 by 2c will discharge through the both the resistors. So from 1 by 2c it will go to 0. It is a source free network. That's the gist, right? So what will happen here, right, at t equal to 0, exactly at t equal to 0, this will behave as a short circuit. So through here delta t by 2 current will flow, through here delta t by 2 current will flow. So your Vc 0 minus will be equals to 0 volt, which will not be equals to Vc 0 plus. Why it will not be equals? Because your IC is not finite. So what will be your Vc of 0 plus? So what is your IO of 0? It is simply delta t by 2. What is your VO of 0 plus? It will be simply Vc of 0 plus, which is simply 1 by c of integration IC dt, right, that is equals to 1 by c into integration of delta t divided by 2. Okay, so this will be 1 by 2c E of t basically. So initial voltage is 1 by 2c, right? Then what happens? Then the circuit is gone at t equal to 0 plus. Your current source is gone, right? Your current source is gone. So only your voltage source is there, okay, at t equal to 0 plus, which is 1 by 2c. So Vc of 0 plus we already know. What is the current now? What is the current? IO of 0 plus, it will be negative because this is my reference direction, but actually current is in this direction. So it will be negative minus 1 by 2c divided by 2r, right, which will be minus 1 by 4rc, and it is a source free network. At infinity, what will happen? This circuit will be open circuited, right? This will be open circuited. So this will also behave as an open circuit. So current through here is 0, current through here is 0. So overall the drop VO also goes to 0. Your IO also. So VO of infinity is 0 volts, IO of infinity is 0 volts. Okay, time constant is 2rc. Okay, so current initially I get an impulse, that is delta t by 2, then it became negative, it reduced, it was minus 1 by 4 rc, and this point is 4 tau. Now for voltage, it was 0 previously. We encountered a step jump 1 by 2c, and then this also it started discharging, so this will go to 0 again in 4 tau. Okay, so what will be the expressions? So this expression will be I t will be delta t by 2 minus of 1 by 4 RC e raised to power minus t upon tau. V of t is equals to e raised to power minus t upon tau. Okay, so yeah, what is the transfer function? So transfer function, right? Current gain transfer function. Now do I have a pole? Pole is same, right? Pole खोल देगा. So pole is same, minus 1 by negative inverse of time constant, that is 1 by minus 2 RC. So your frequency, right? Pole frequency is 1 by 2 RC. 0 0 0 0. Do I have a 0? No, there is no possibility of having a 0 here. Is there, like this will be, yeah, I actually have a 0, sorry, I have a 0. So if this is infinity, right, no current will flow through here, all the current will flow through here. So at s equal to 0, this will provide infinite impedance. So sz is 0 simply. So I have a 0 at s equal to 0. So what will be my transfer function? H of s will be a into s upon 1 plus s to RC. So DC gain is 0, right? DC gain is 0 because current is 0, right? IO is 0 at 0 frequency. So DC gain is simply 0. Okay, DC gain is 0. What about high frequency gain? High frequency, this will behave as a short circuit. What is the current at high frequency? Current at high frequency is, this will behave as a short circuit, right? So in DC, this will behave as an open circuit. So that's why the current here is simply 0 in Laplace, right? At s equal to 0. At s equal to infinity, this will behave as a short circuit. Okay, so this will be I of s divided by 2 basically, because both of them are providing equal impedance. So my IO of s, right? IO of s is simply I of s divided by 2. So high frequency gain actually, right? IO of s upon II of s. Will be actually 1 by 2. That is my h of infinity, right? H of infinity sounds cool, right? So now infinity, this is happening. So if I put here infinity, right, in the transfer function expression, if I put here s equal to infinity, this will be a upon, I will only take the coefficient of s, right? Those will be dominant, upon 2 RC. This must be equals to 1 by 2. So from here my A is equals to RC. So from here I can say my h of s equals to SRC upon 1 plus S to RC. So this is the transfer function. I'm getting a 0 at s equal to 0. So, and what is the gain at s equal to 0? It will be something 0 only. So negative. I will start off from negative, right? I will start off from negative and slowly I'll go towards 0 dB. Okay, because I have a 0 at s equal to 0, so this will be plus 20 dB per decade. Then what is happening? I encounter a pole at 1 by 2 RC. So after that the slope will become constant and this magnitude also will be always constant. Is that correct? Am I correct? SRC plus 90 is constant. Yeah, magnitude is constant because your high frequency gain, right, is constant. So I can say what is the value of this constant magnitude, that is minus 20 of log of 2, right, because I know the high frequency gain. Minus 20 of log of 2, this will be the value of the high frequency gain. What will the phase? So I have a 0 at s equal to 0, so that 0 will provide me plus 90 degree phase shift, right. Then 10 times before, so what is my pole? It is 1 by 2 RC. 10 times before it, that is 1 by 20 RC, I will encounter a pole and it will remain till 5 by RC. 1 by 20 RC, 5 by RC. Okay, this is my pole actually, 1 by RC. This will be 1 by 2 RC. This will be 45. Zero dB per decade. Okay, so that's the transfer function basically. Okay, because at s equal to infinity the gain is constant, that is plus 1 by 2, that is what is the phase? 0 degrees, right. So it will start off at 0 degrees. Now what about the trans resistance? So it's very simple, right. Trans resistance, I have a capacitance connected as a output, right. So my what will be my V of s? It will be I of s divided by C of s, right. So V of s upon I of s will be simply 1 by Cs into IO of s upon I of s, that is equals to SRC upon 1 plus 2 SRC. So Cs will get cancelled, so this will be R upon R plus 2 SRC. Okay, R upon 1 plus 2 SRC. So that is the trans resistance. Now at DC the gain is constant, that is 20 log of R. Then I encounter a pole, so then the value will only keep on reducing. Okay, so 20 log R, this will be minus 20 dB per decade, and I encounter a pole at 1 by 2 RC. Can you tell me what is the unity gain frequency? Will be bit difficult to find out when the bottom also goes to R, when the magnitude of the bottom is R. Actually the bottom is R, so basically 1 plus 2 omega square R square C square equals to R square. Yeah, it will be difficult to calculate. You can calculate, but that is a homework for you. Okay, so now the phase, what will happen to the phase? Now I don't have a 0 at s equal to 0, I just have a pole. and at s equal to 0 DC the phase is 0 because it is plus r, right? Transfer function is plus r. So we'll start off with 0 degrees, then I will roll off to minus 45 per degree per decade. Okay, so this slope is minus 45 degree per decade slope. Okay, this will start off with 0. I'll start off with 0, and this effect, it will not be infinite, it will remain till 10 times the pole. So this is my pole location, that is 1 by 2 RC. So it will start off from 1 by 20 RC and it will end at 5 by RC, and I will get minus 45 degree. Okay, and this will end at minus 90 degree. Okay, so let's now solve the next one. So next one, just the there are two capacitors instead of a um, single capacitor. So what is the order of the circuit? Here I have two energy storage elements, right? But again, if I fix the current here, IC1, the current here also will be fixed, that is I1 II minus IC1, right? So it is a first order circuit because I have only a single independent energy storing element. What is the time constant? It's again very simple. This time what I will do, I will remove the energy storing element. Basically this capacitor and this capacitor are in series, so it will be tau will be R into C by 2. Okay, that is the time constant here basically. I hope it is clear. So now we will solve the unit step and impulse response. So again, what is happening at t equal to 0, right? These are providing 0 voltage, and at t equal to 0 plus, what is happening? At t equal to 0 plus, some finite current will flow. This is short circuit, right? So some finite current is flowing 1 ampere because this part is providing R resistance, this path is providing short circuit. So all of the current will flow through here. All of the current will flow through here, correct? Then what will happen? Then basically yeah, I was just lost in thought. Then what will happen is that this will slowly, voltage will increase, and if voltage increases, some current will flow through here as well. So this will also energize, and at steady state this will be open circuit, this will be open circuit, but that is again not valid, right? Because then the current will become constant, because both of them will provide some constant both of them will provide some constant impedance, that is C and C. So current will be 1 by 2, it will be a ramp function. Current will simply be a ramp function. Okay, it's very simple. So like this analysis we have already done, so we are just repeating the same analysis. So Vc 0 plus will be equals to Vc 0 minus, because your IC will be finite. So if I draw the circuit over here at t equal to 0, half current will flow through here, right? Half current will, no, full current will flow through here, because this will behave as a short circuit. So 1 ampere of current will flow through here, and through here 0 ampere of current will flow, right? So this is the circuit at t equal to 0 plus as well, 0 and 0 plus, both circuits are same. So my IO of 0 plus, that is equals to 0 ampere, my Vc of 0 plus also equals to 0 volts, which is my VO of 0 plus, right? This is actually, this is a simpler version of the previous question, actually previous to previous question, right? So what will be happening at infinity? Infinity, both of them will provide high impedance, right? Both of them will be C and C. I can neglect the resistor. The resistor can be simply neglected because the voltage across resistor will be much smaller than the voltage across the capacitor. That's why we can assume the resistor to be just behave as a short circuit. So at after a very long time, this current will be 1 by 2. This current will be 1 by 2. So current is constant. So IC of t is 1 by 2. So your VC of t will be integration of IC of t dt over C. So this will be simply 1 by 2C into t u of t. This will be the expression for voltage, and current is fixed 1/2 ampere. So the value will be IO will start from 0, it will go to half, and your VO will just be a ramp function. That's it. Will it be amp? No, initially it will be exponential. Initially it will be exponential till 4 tau, right? Then almost it will be a ramp function. Okay, so the slope here will be 1 by 2C. Initially it will be non-linear, then it will be linear. So my I of t equals to 1 by 2 1 minus e raised to power minus t upon tau. Tau is RC by 2, and this graph will be like I cannot draw for t equal to for t much larger, right? V of t steady state I am drawing, that will be equals to 1 by 2C t into e of t. Initially there will be some exponential, like non-linear function. I am not writing it. Okay, so that was the step. What is the unit impulse? Impulse again simple, right? Again impulse current will flow through this. This will be short circuit, so this voltage will instantaneously change. This voltage will still remain because no impulse current will flow through here, because this is allowing short circuit path. So this voltage will change to 1 by C, and this will be disconnected. So then this 1 by C will discharge through this capacitor, and ultimately you know that both of them will settle to with charge conservation, because whatever charge comes out, same charge will go in. Both of them will settle to some constant voltage. At infinity the current will go to 0. Okay, so what will happen over here at 0? Okay, what happened? Okay, my pen tab also is somewhat lagged. Okay, something has happened. It is not responding to my touches. Okay, now it is responding. So we have been recording for quite a while. I am also exhausted right now. Okay, so this, right, delta t, this also will behave as a short circuit. So all of the current will flow through here, right, which is infinity. So basically my VC, let me name this as C1, let me name this as C2. So VC1 equals to 0 volt, VC1 of 0 minus equal to 0 volt, which will not be equals to VC2 of VC1 of 0 plus. Okay, then your but your VC2 of 0 minus will be equals to 0 volt, which will be equals to VC2 of 0 plus. This will be equal. This will be equal. So what I can say is, what will happen, because your current IC1 is not finite, so your VC1, right, VC1 will become at 0 plus, this will become, I can integrate this value, right, delta of t integration by C, right, so it will be 1 by C basically. But your VC2, right, or your output voltage is still 0, because there is some finite current, like there is 0 current, because IC2 of 0 plus is still 0 ampere current, right, so there is no problem with IC2, but with VC2 there is problem. Okay, so this was a circuit at t equal to, exactly t equal to 0. At t equal to infinity, what is happening? Sorry, not t equal to infinity, at t equal to 0 plus, what is happening? T equal to 0 plus, right, the C2 capacitor will still hold its voltage, and C1 also will hold its voltage, that is 1 by C. This will be short circuit, and what will happen, IO will, it will simply discharge, right. So I can use at t equal to 0 plus. So at t equal to 0 plus, we have already written down the conditions. I will directly draw the infinity circuit, t equal to infinity circuit. So t equal to infinity circuit, this will be infinity. So both of them, right, will discharge to same value V and V. So I can use the charge conservation principle. So 1 by C into C will be equals to V into C plus V into C. So ultimately they will settle to 1 by 2 volts. Okay, they will settle to 1 by 2 volts. That will be your infinite voltage, right, V of infinity, and I of infinity is obviously 0, right. And what was the initial current? Okay, we did not discuss the initial current here, right. What is the I of 0 plus? I of 0 I know, I of 0 is 0 only, right. Sorry, IC2 of 0 plus is actually not 0, it is some finite value, it is not 0 actually, sorry. IC2 of 0 is 0, IC2 of 0 plus or I of 0 plus will be from defined from this circuit, right, that is 1 by C by R, that is 1 by RC, 1 by RC. So the current, right, previously it was 0, then it went to 1 by RC, then it went to 0. Okay, it is 4 tau, this is 1 by RC. Okay, now here the current, voltage, what will happen to the voltage? Voltage also initially it will be 0, then it settles to 1 by 2 volts, correct. 0, previously it was 0, 0, then 1 by 2 volts, right. So this will be the graphs basically. So my current IO of t will be 1 by RC e raised to power minus t. What is tau? Tau is RC by 2. T upon tau. And here this will settle to 1 by 2 volts. So your VO of t will be 1 by 2, 1 minus e raised to power minus t upon tau into E of t. Okay, into E of t. This also will be into E of t. Let's do the transfer function. So poles is very simple, minus 2 by RC, it is negative inverse of time constant 0. So at s equal to 0, right, this is infinity, this is infinity, so all current will flow. At s equal to infinity, this is shorting, right, so all of the current will flow, but that is not a finite 0. So no finite 0, no finite 0. So there is no 0 basically. So your transfer function will be h of s will be equals to a upon 1 plus SRC divided by 2. Okay, so if your S is 0, right, if S is 0, DC gain is what? These will dominate, so current will be IO by 2, so your gain is 1 by 2 basically. DC gain is 1 by 2, so your A will be 1 by 2. So your transfer function is 1 by 2. At high frequency, what is happening? All of the current will flow through here. So your IO will be 0. At high frequency, this is anyway 0. Okay, high frequency gain is 0. So if I write the transfer function, H of S will be 1 by 2 upon 1 plus SRC upon 2. That is what your H of S will be. So it's very simple. It is 1 by 2, right? DC gain is half, so it is something negative. Start from below 0 dB axis, then I will encounter a pole. -20 per decade. This will be -20 log 2. Okay, negative. What about the phase? Again, I just have a pole at S equal to 1 by 2 RC, right? So this value, right? 2 by RC. Initially the phase is 0, then I encounter a pole, due to which the slope will be minus 45 per decade, degree per decade. Then again the effect of pole will go away 10 times after it. So this will be the pole location 2 by RC. Okay, and this will be the location minus 90. This will be minus 45. So (20 by RC) and 5 by RC. Okay, so yeah, that's it basically. Okay, that is it. I guess that is it, right? Oh, this slope, I have to mention this slope. So this slope is minus 45 per degree per decade. Okay, what is the trans resistance? So trans resistance, right? This time I have a capacitance connected, right? CS. So basically a 0 pole will be added. It will behave as a second order circuit. So what will happen? I need to find out my VO of S over VII of S. So that will be basically equals to 1 by CS. Like basically my VO of S is 1 by CS into IO of S, right? So your transfer function will become 1 by CS into 1 by 2 divided by 1 plus SRC divided by 2. So ultimately, right, this will be 1 by 2 C divided by S into 1 plus SRC divided by 2. So so at S equal to 0, right, I am getting very high gain. So it will start off from positive infinity. Graph will start off from positive infinity and it will roll off, right? Graph will start off from positive infinity, it will roll off till I will encounter a, okay, sorry, I encounter another pole. There is no 0 actually. There is no 0. Okay, there is no 0. So this will be the graph. So this slope will be minus 20 dB per decade. Then I encounter another pole. So the slope became at 2 by RC. So the slope became minus 40 dB per decade because I have two poles now. Two poles are coming into effect. Okay. What about your homework is finding this unity gain frequency. Now what about here? What is the phase? So for phase, right, what do I see? For phase at S equal to 0, this will provide plus, sorry, minus 90 degree phase. So I will start off with minus 90. Start off with minus 90. Then 10 times before it, right? This, that is at 5 sorry 2, so yeah, 5 by RC. Just give me 1 second. Yeah, 5 by RC. This effect of this pole also will be taken into action. So the slope will be minus 45 degree per decade. It will go on till 20 by RC. It will go on till 20 by RC 10 times after. So the pole is here, that is 2 by RC, right? The pole is here, so this will be minus 135 degree basically, right? And this will be minus 180 degree. Okay, so the pole is here, minus 180. Why? Because at infinity, right, this is providing minus 90 and this also will provide minus 90 at infinity, so that's why minus 180. So after 10 times the effect of that slope goes away. So these are the like Bode gain and phase plot. So let's now solve this one. So now, right, from now onwards, what I will do is I will, like these circuits, right, previous circuit also was almost same, like we had already done the analysis, so but still I did the analysis. But now onwards what I will do is, as we have already solved, if you remember, we have R here and CR, that has been already been solved, but this time the output voltage I am taking from a different point, but the current is same. If you remember, the circuit G is exactly same as circuit I, just the C and R are interchanged, right? So your VO will change, IO will remain same because I have just interchanged the R and C. Okay, that's it. So your IO will be same, IO of T will be same, but your VO will be different. So the analysis also you can do by yourself. Okay, I hope current and voltage, all those things are same. So these are the plots for the current and voltage for circuit G. Okay, so the current here was reducing and the voltage was like getting stationary to R. It was settling to R because this was getting open circuit. So at steady state, what will happen? All of the current will flow through this. So this potential will be R. But here what is happening in circuit, this circuit, that at steady state this will be open circuit. So there will be no current. So this voltage also will be 0. So VO will go to 0. Initially what will be the voltage? This will behave as a short circuit. Initially it will be R by 2. So initial voltage will be R by 2 because I by 2 current will flow. So that's why initially the voltage will be R by 2 and then it will settle to 0. It will just be the multiplication of the current. VO of T is IO of T into R. So your current graph will be exactly carbon copy. There will not be any difference in the current graph because the previous one and this one is same. Start from half, end at 4 tau. Tau also will be same. Time constant will not change. I am just taking the output from a different point. Tau will be same. Tau will be same. Tau will be equals to 2RC. Okay, and your VO will just be proportional to IO because VO is IO into R. So it will also be R by 2 and it will settle to 0. R by 2 settle to 0 at 4 tau time, right? So the current value will be same expression. The voltage expression will be just multiplication of R. That's it. Okay, that's it. What about the impulse? For impulse, what was happening in this circuit? For impulse, at t equal to 0, this was behaving as a short circuit, right? Okay, this circuit, yeah, this was behaving as a short circuit. So both of them, delta by 2 current was flowing. So this will be charged to instantly to 1 by 2C. This will be charged to voltage 1 by 2C. So due to that, there will be sudden change in voltage. As we can see here, this got charged to 1 by 2C. Then it became a source free network because this current source was removed. So basically it decayed, right? It decayed to 0. Okay, because it was discharging through the both the resistors. But what will happen now here? Here current waveform is what? Current waveform is this, right? Because at t equal to 0, again delta by 2 current will flow. Then after that this will get charged. So some current will flow in this direction, that is negative of IO, that is minus 1 by 4 RC, which is same as the previous one only. and then it will decay down to 0. So current waveform will be same as current waveform here. In the new case, voltage will be just the multiplication of the current with R. Okay, so I can simply copy this thing, right? I can simply copy this thing and paste this over here, and the voltage will just be product of the current. So I can again delete this, right? I can just copy this, and here I will have to just multiply by R to make it voltage, because VO is equals to IO into R. So here everywhere there will be a R term, so this will be R, this will be R by 4RC, that will become 1 by 4C. This will become 1 by 4C, because the voltage will get equally divided between this R and this R. 1 by 2C will get equally divided between this R and this R. Okay, then it will decay down to 0. So your voltage expression here will be VO of t, this will be R delta of t into 1 by C e raised to power minus t upon tau. Okay, so that is what your voltage expression will be. Now what about the transfer function? So for transfer function, will there be well, like pole is same, right? Pole is negative inverse of time constant, so your pole will be same, that is negative inverse of time constant, that is equals to minus 1 by 2RC. So your omega p will be 1 by 2RC. Okay, omega p will be 1 by 2RC. Just give me 1 second. What about 0? So for me to have 0, right, either this drop should be 0, so that it provides, either this current will be 0, right, then this drop, sorry, yeah, this current IO, I have to make it 0, right, or all of the current has to flow through this. Either this has to be open circuit or this has to be short circuit. So what I'm observing as, I can make this one open circuit. How? At S equal to 0. At S equal to 0, this will provide infinite impedance, so no current will flow, right? IO will be 0, all of the current will flow through here. So we have a 0 at S equal to 0. Okay, so my transfer function will be H of S A into S divided by 1 plus S2 RC. This will be a transfer function. Okay. So what is A? A will be the, A is nothing, A is just a constant number, we will find out A. So DC gain again, right, at S equal to 0, IO is 0, so DC gain will be simply 0. What about your high frequency gain? So at high frequency, what is happening at high frequency, this capacitor, so this will behave as an open circuit at DC gain, right, at S equal to 0. And at high frequency, capacitor behaves as short circuit. Behaves as short circuit at S equal to infinity. So if it behaves as a short circuit at S equal to infinity, so my, from this I can find out my IO over IO of S over II of S will be equals to 2. Okay, sorry, not 2, 1 by 2, right, half, it will be half, because both of them, both these paths are providing RR impedance, so it will be half. Okay. So what is the H of infinity? H of infinity will be H of infinity will be A upon, I will just take the coefficient of S, right, A upon 2 RC, that will be equals to 1 by 2. So from here my A is RC. Okay. So what will be the final transfer function? Final transfer function H of S will be SRC. Like I think this is the same transfer function that we, because current gain will not change, right, current gain will not change, current gain will be same, right. So but the voltage, now the voltage transfer function will be different. Okay, SRC upon 2 SRC, this will not change basically. So we encounter is 0 at S equal to 0, so my slope will be positive, and when my S is very low value, right, when my S is very low, this is anyways neglected, this will be something less than 1, so I will start off from negative, and then at S equal to, at omega equals to 1 by 2 RC, I encountered a pole, due to which the overall slope became 0 only, because pole provides a slope of 0, like minus 20 dB per decade, and already I had plus 20 dB per decade. Okay, plus 20 dB per decade, and this is 0 dB per decade. So yeah, so that is clear. So what will be this value? Can you find out this value? This value will be at S equal to 1 by 2 RC. S equal to 1 by 2 RC, this will provide under root 2 magnitude, and this will be 1 by 2, so 1 by 2 root 2, so log of 1 by 2 root 2, right, that will be the magnitude, you can find it out. So this will always be below this axis. Why? Because what is the high frequency gain? High frequency gain, if I see the high frequency gain here is 1 by 2, right, sorry, this will not be 1 by root 2, this, right, this will be equals to my high frequency gain, right, and high frequency gain is 1 by 2, so which is less than 1, so I will always lie below the 0 dB axis, I will never go above the 0 dB axis. What will be this value? This value will be log of, this value will be simply equals to high frequency gain, that is minus of 20 log of 2. Okay, and what will be the angle? At S equal to 0, it is providing a phase shift of plus 90, and then at S 10 times before it, we'll encounter the effect of pole, that is at omega equals to 1 by 5 RC, sorry, it is 1 by 20 RC, and I will, this will go on till 10 times after the pole, that is 5 by RC, and after that the phase shift will be simply 0. Why? Because at infinity the gain is plus half, which is providing 0 degree phase shift, so plus 90, and this will be minus 45 degree per decade. Okay, so now let's solve for the trans impedance transfer function. So I know that my VO of S, right, is simply equals to IO of S into R. So nothing will change actually, just a R, a constant number will be multiplied, phase plot will be exactly carbon copy ditto. Okay, So here my h of s will become, this time trans impedance will become, here I will have a r square basically, that's it, right? It will be IO, VO upon IO, VO upon II, which is IO into R upon II, IO into R, IO by II is SRC upon this value. So I just need to multiply R. So what will happen? Either like now it can go above the, now what is the gain here? What is the high frequency gain? High frequency gain h of infinity will be R by 2 now. Okay, it will not be R. So this R, if R is greater than 2, then my graph can lie above the 0 dB axis. Okay, so the graph will be somewhat like this. It depends on the value of R actually, but I hope that you can do. So then I will have this, like overall the shape of the graph will be same, but the locations will differ. This will be 1 by 2 RC, and this high frequency gain will be log of R by 2. Okay, and the phase plot will not change at all, because I'm just multiplying a positive number, and we know if I multiply a positive number, it does not change the phase at all. Okay, does not make any difference to the phase. So phase plot will be same, carbon copy ditto. I can copy this phase, right? There will not be any changes at all in the phase plot. Okay, here, okay, this came here twice, current gain transfer function, this came actually twice here. Okay, fine. Now let's solve the next one. So next one is also again simple. This we had just solved in circuit H, right? We had just solved this in circuit H. Same. What have we done? We have just replaced the resistor with capacitor. So this will again become more and more simpler. So my IO will be same, right? What is happening if I am providing a unit step input here? If I am providing a unit step input here, basically at t equal to 0 plus, both of them. So through this all of the current will flow, because this will totally provide short circuit path. So here current is finite everywhere, so there will not be any impulse current. So voltage also will be fixed, like Vc0 minus will be equals to Vc0 plus. Then at infinity both of them will provide high impedance, so current will get equally divided, because most of the voltage drop will be across this capacitor. This I can neglect. So again it will be 1 by 2, 1 by 2, right? So that is what will happen here as well, that here Vc0 minus will be equal to Vc0 plus, and initially there is no change in the like current is 0 initially, so voltage also will be 0 here. VO equals to IO into R. Okay, so here, right, what will happen? Current will be initially 0, then slowly it will increase to half, because at infinity, at steady state, both of them will provide infinite impedance. Okay, so here the difference is my VO will be IO into R, and IO will be simply same. Okay, IO will be simply same. So the plots, right, current plot will be exactly carbon copy ditto same, because this I have just replaced the RNC, right, swap the RNC, not replace, swap the RNC. So current will be ditto same, and voltage will be just the multiplication of the current. Okay, so I can copy the current plot. And voltage will be just the multiplication of the current plot, multiplication into R, right, because VO is IO into R, because I am taking the voltage across the resistor. So VO will be IO into R by 2. So this will be R by 2, this will be VO. That's it, no change. Okay, that's how simple it is. What about the impulse response? So impulse response, again same thing, right? Initially all of the impulse current will flow through this capacitor, so this voltage will hold. Here also initially all of the impulse current will flow through this, so this voltage will be still 0. Then this has been charged to 1 by 2C, that will get divided between both the two capacitors. At steady state, this potential and this potential will be same, so that there is no current through the resistor, right? That is what we derived here. At steady state the voltage became 1 by 2, right? So we can solve it actually, but that will be the voltage across the capacitor. The voltage across the resistor will be 0 because the current across the resistor is 0. So I will again copy the current graph. Current graph will be same. Voltage will be just the multiplication of the current. Tau does not change. So I hope one thing is clear, that time constant, right? It is actually, it does not depend where you are taking the output, right? It depends where you are providing the input. So one conclusion I will say at the starting, right? At the starting itself I will say your time constant, here I will write down the conclusion at the starting itself. Your time constant depends on the type and location of the input. Okay, now like time constant is related to poles. Okay, so will the poles also be same? So one thing is that here, right, this statement is valid for resistive elements. Okay, but because resistance does not add or remove any pole while calculating the current or voltage, right? Because it does not matter what is the output, right? Output can be either voltage or current. For a resistor, a constant either 1 by R or R will be multiplied. So the poles also the same statement can be written for the poles as well. Okay, in case of a resistive element, right? If I'm talking about when valid when I'm taking when output is taken across a resistive element. Now if I take that output across a capacitive element or inductive element, then things can be different, right? So if I have calculated the current transfer function, right? Current gain transfer function, right? For a capacitive element, I know that the current IO and VO. Now let's say I am talking about the voltage, like impedance transfer function. If he is asking what is the poles of the voltage, like output voltage and input current, then how can you say? Then right, what happens? Your output voltage is what? Output voltage will be 1 by Cs into IO of S. So basically what happens? A pole at S equal to 0 gets added. A pole at S equal to 0 gets added. Okay, so you have to be careful actually. So the order actually increases, but if there is a 0 at S equal to 0, then order also, there is a pole 0 cancellation, order remains same. Okay, order may increase, order will increase if there was no 0 at S equal to 0. Okay, so you have to be careful all this regarding all this, right? All these things should be in your mind. Let's now move on to whatever circuit we were in. So we were in, not here, this circuit, right? Yeah, we were here, I guess. Yeah, this circuit. So here, right, again what will happen to the transfer function? Poles will be same. SP will be minus 1 by tau, which will be equals to minus RC by 2, that is 2 by RC. RC by 2, 2 by RC. So my omega p is same, that is 2 by RC. 0. What about 0? Do I have a 0 again, right? At S equal to 0, both of them are providing infinite impedance. So current is half. So this gain is finite at S equal to 0. So DC gain is finite. At infinite gain, yeah, this will be short circuit. So all of the current will flow. So at S equal to infinity, we have a 0. So the 0 is not finite. So we don't have a 0 basically, not a finite 0. Right? So no 0. Now here, what is the DC gain? DC gain will be basically, I have to short both open circuit both the capacitor, because at S equal to 0 both of them will provide very high impedance. So the current will simply get divided, right? This will be II by 2, capital II of S by 2. This will be II of S. So your IO of S divided by II of S will be 1 by 2. So DC gain, right? A is 1 by 2. Your transfer function, right? What will be your transfer function? Your transfer function H of S will be A upon 1 plus SRC upon 2. That is what your transfer function will be equals to. So here also high frequency gain is 0 basically. If you put S equal to infinity, right, all of the current will flow through the okay, inner capacitor, not through the output. So this will become short circuit. Okay, so this will be 0. S. So this will be 0. So your high frequency gain will be simply H of infinity will be simply 0. That can be seen from the transfer function as well, right? That can be verified from the transfer function. So your transfer function, like it is the same transfer function, that is 1 by 2 upon 1 plus SRC upon 2. Okay, so yeah, at S equal to 0 it is negative, so DC gain will start up from 0 and then I will have a pole, so I will then decay down to minus infinity. This value will be minus 20 dB per decade, this value will be 0 dB per decade. Okay, and this value will be minus 20 log 2. What about the phase? So phase is again like at 0 we are getting 0 degree phase, and at 1 by 20 RC, this should be RC by 2, hold on a second, oh no, I have two capacitors. Okay, yeah, 1 by 2 RC, 1 by 20 RC I will encounter the effect of pole, and it will go on till my phase becomes minus 90 degree. Okay, this will not be, so this will be 2 by RC, right? 2 by RC 10, so this will be 1 by 5 RC actually. This will be 1 by 2 by RC, and this will be 20 by RC. Okay, I hope the look. So here this is 2 by RC. I will just quickly verify the location on the location of poles in the previous question. I hope I have not made a mess up, right? This will be 45. This will be 1 by 2 RC. Yes, this is correct. 45 degrees. Yeah, 1 by 2 RC. Yeah, it is correct. Yeah. This will be 1 by 2 RC. Okay. Now next, right, next is okay, I did not, okay, I forgot to draw the voltage. Voltage will be just the copy of the current, right? I forgot to draw it at that point of time. Voltage will be just the copy of current, just multiply it with R. This will be multiplied with R. This will be 1 by C. Okay. So what about the trans impedance transfer function? I have to just multiply this with R, right? An additional R will be multiplied, that's it. Which will change actually? Not much. Which will not change much. This will be multiplied with R, right? So which will just shift the graph upwards. That's it. Because R might be greater than, much greater than half. So that will just shift the graph upward. Other than that, nothing much will change. Two by RC, and this will be 20 log of R by 2. Okay. So what about the phase plot? Phase plot will be exact replica. Phase plot will not change, so it will be half. So we'll just copy the previous one, because we are just multiplying a positive number, that is R. Nothing will change for phase. Phase plot will be exact replica. Okay. Let's now move on to the next one. So this one is interesting. So here, like this circuit we have solved already, right? It is this circuit that we have already solved. So we already know the current, right? So we just need to find out this voltage across C2, because IO will be same. IO is same. The voltage will be what? Integration of IO of t, or in Laplace domain it will be IO of S upon CS. So that is what happened. Voltage will be different, current will be same, right? So I am not repeating the same analysis. We have already done the analysis. Okay, sorry, voltage will be different, current will be same. So I will not repeat the analysis. You can go through the analysis over there. So intuitively I can discuss regarding the voltage. So initially 1 ampere of current is coming here. Both of them will behave as short circuit. So initial, again, this is finite current, right? So both of them are providing R1 R2. So some current will flow through both of them, which is finite. So V of 0 minus will be same as V of 0 plus, which will be 0 volts. Then at steady state, what is happening? Both of them will be providing very high impedance. So again, half current will flow. Again, what will happen? The voltage will increase linearly. Okay, voltage will increase linearly because the current here is constant half. That's as simple as that. And current is already shown here, that it will start off with R1 divided by R1 plus R2, because it will initially it will be just like a resistance divider, and then what will happen? It will be just like a capacitive divider. So finally the current will be C2 divided by C1 plus C2, C2 divided by C1 plus C2. Okay. Now we had assumed that this value, initial current, was greater than the final current. So this condition we had assumed, that C2 R2 is less than C1 R1. Okay. So the current graph will be exact replica. There will not be any difference in the current graph. And voltage graph also will be actually similar only, because we know that initially there will be bit of resistive effect, due to which the voltage will be different, right? But at steady state it will be linear function, because at t infinity the voltage of the capacitance only dominates, right? So that's what we discussed roughly. So this voltage waveform will be again copied, because at t equal to 0 plus during the starting, right, before 4 tau the voltage waveform will be different, but at infinity it will just follow the ramp voltage, because at steady state the voltage across the capacitor in that circuit as well, in this circuit voltage across the capacitor dominates over the voltage across the resistor, because this will be very high. So the voltage graph also will be roughly the same, current graph also will be roughly the same, voltage graph will be also the roughly same, there will not be much of a difference. Okay, right? For impulse as well same thing will happen. For impulse that we discussed there, that if I am providing some impulse here, delta t by some multiplication of r1 r2, and here also delta t some multiplication of r1 r2. So delta t current flows like it is some x into delta t, x into delta t, y into delta t. So still it is delta t, still it is infinite current. So my voltage will certainly change. It will rise up to what value we discuss. In case of a capacitor it will rise up to some like a naught, because a naught will be combination, a naught will be combination of both the this drop across the resistor and C2. We discuss, we derive the value of a naught as well there. Okay, but here actually we can directly say what will be the value of a naught. So initially what is the current through this capacitor at t equal to 0? It is R2 divided by R1 plus R2, right? That into delta of t. Sorry, R1 divided by R1 plus R2 into delta of t. So what will be the impulse? What will be the voltage change? It will be this integration divided by its own capacitance, that is C2. So this will become the voltage actually at t equal to 0 plus will be C2 1 by C2 into R1 divided by R1 plus R2. This will be the VO as well. So this will be my VO 0 plus. Current will not change obviously. Current is same only. It is a series circuit. Current will not change. But VO 0 plus, now I have a number here. I have a value, that is R1 divided by C2 into R1 plus R2. This is the number, and then what will happen? Then this impulse is gone, and then what will happen? Then some charging or discharging will happen. We discuss that we discuss that it will discharge. Why? Because this value will be higher. Why? So what is the amount of voltage at the other capacitor? Amount of voltage at the other capacitor, that is C1. VC1 will be R1 R2 divided by C1 into R1 plus R2, right? We proved at that point of time, that this voltage was actually lower than the VC1 voltage. So that's why this VC1 voltage will be lower than VC2 voltage. We discussed that VC2 will discharge, right? So if VC2 discharges, then this will basically go towards 0, and the current will be negative, that can be observed from the current graph as well. Current will be negative, that can be observed from the current graph. So current graph will not change, current graph will be same only. So I'll delete these things. Okay, current graph will be same, but the voltage graph will just be a bit different. It will be this graph only. Okay, at steady state what is happening, we discussed it will settle to 1 by C1 plus C2. Basically the voltages across all the because this drop was 0, right? At steady state the current was 0. So anyways, whatever was the voltage across the capacitor, that would have been the output voltage at steady state. This current was 0, so this voltage drop is 0. So whatever was the voltage across VC2, the same voltage will happen here. So we are anyways taking the voltage across VC2 only. So this as steady state voltage will be same in this graph as well. So it will discharge to 1 by C1 plus C2. Okay, at 4 tau time. And what will be the voltage equation now? VO of t, initial value is this R1. So this will be 1 by C1 plus C2 plus R1 divided by C1 plus C2 into R1 plus R2. minus T upon RC, T upon tau into U of t. Okay, so whatever the transfer function, so transfer function, right, current transfer function will be same, IO over S over IIO of S. So pole will be same basically because current transfer function is same. So your SP will be minus 1 over negative of time constant, that is this time it will be minus 1 over R1 plus R2 into C1 parallel with C2. So your omega p will be simply 1 by magnitude of tau. What is a 0? So I can get a 0 if this is short circuit, all of the current will flow through here. So I have a 0 at S when this impedance is gone to 0. So that is R1 plus S1 by SZ C1, that is equals to 0. So SZ equals to minus 1 by R1 C1. So my transfer function H of S will be A into S R1 C1 plus 1 divided by 1 plus S tau. Okay. What about DC gain? DC gain, both of them will provide infinite impedance. So the current, right, will be equally divided because this, right, this will, the capacitance will be dominating because it will have higher voltage drop. So it will get divided in terms of the value of C1 and C2. So my DC gain H of 0, that is equals to A, will be equals to what will be the output current? Output current will be C2 upon C1 plus C2. Okay. And what about the high frequency? At high frequency, both of them will behave as short circuit. The capacitors will behave as short circuit. I will have resistors. So the voltage division will happen on the resistors, depending on the values of resistors. R2, R1. This will be short circuit. This will be short circuit. Okay. So now here right, my H of infinity becomes simply R1 divided by R2 plus R1. So we discussed that my R1 C1 was greater than R2 C2. That is what we discussed, if you remember. So the Bode plot will not change because the transfer function has not changed at all. Transfer function has not changed at all. Bode plot also will be same. So Bode plot will be same. I am not drawing it. Okay, Bode plot will be same. Just for the trans impedance, what you can do, you know, your VO will be equals to VO of S will be equals to 1 by CS into I of S. Okay. So an additional pole will be added. That's it. An additional pole will be added. Okay. So yeah, that is what you have to take care. I think we have discussed about this, so I'm not repeating it again. Now this, right, this one is again simple, not that difficult. Just I have swapped my C2 and R2. So basically your current will be same and your voltage will be I of t into R. So I hope I I like what will happen. So current will be same. So I will copy the current. Okay, I hope I don't need to analyze, and the voltage will be just the multiplication of the current R into IO of t. So this current will be same. Cut this. And voltage will be just the multiplication of current. So here I will have the multiplication of current. This will be VO, and with all of this I will multiply a resistance R2. That's it. With all of this expression I will multiply a resistance R2, that will be my voltage. So here this will become R2. I will make it bigger. This becomes R2. This also, the steady state current becomes R2 into C2 divided, steady state voltage becomes C1 plus C2. Okay, that is equals to my V2 VO. So that's it. Impulse also, everything will be same. Your current waveform will be same. Just your voltage will be IO into R. So I'm not analyzing it because we have already analyzed the circuit. Okay, I hope that is fine by you guys. Voltage waveform will be this will be R2 with current, a voltage simply will get multiplied. That's it. Into R2. Okay, so that is the case over here. Now pole zeros, everything will be same, right? Pole zeros, everything will be same because okay, current transfer function is not changing, so everything will be same. Everything will be same. Pole zero, everything will be same because current transfer function is not changing. This IO and the previous circuit, this and this, right? IO is same. So the current transfer function is not changing. Current is same. Output current is same. So current transfer function will be same. Just in case of voltage transfer function, what will happen? Your VO of S, right? For voltage transfer function, sorry, for trans impedance transfer function, VO of S this time it will be just multiplication of R into IO of S. That's it. So this is just a constant multiplied. So this will also not change much. That, like, this is the homework for you guys. I hope these things you can go do. Okay, now these last two circuits are there. These are these same circuits or different? These are also kind of same circuits only. Okay, these are also same circuits only, because what you do here, you make R and C everything equal. If you make R and C everything equal, what is happening to the output voltage? So this R and C, right? R and C are in parallel basically. So this is open ended. So through here current is 0. Through here current is 0. So both of them are basically this circuit with R1 C1 equals to R2 C2. It's a special case basically. R1 C1 equals to R2 C2, both of them. VO is across something else, I will discuss about that. But as the circuit is symmetrical, right, it does not matter which capacitor, across which resistor I take the voltage or across which capacitor I take the voltage, because R and C both are equal. It does not matter. These are in series, these are in series, overall this combination is in parallel. So my VO is a voltage across a resistor and a voltage across a capacitor, or it is voltage across this capacitor and the voltage across this resistor. It does not matter because R1 C1 is equals to R2 C2, everything is equal. I can redraw my circuit like this. So this actually is much simpler. So what will be the current through here? So this will always provide equal impedance. These two will always provide equal impedance. So current will always be divided II of t divided by 2. So your transfer function, right, it becomes a zero order circuit. What is the order? It becomes zero. Actually, even though there is number of independent energy storing element is 1, it becomes a zero order circuit. Why it becomes a zero order circuit? Because across what I am taking the output, I am not taking the output across a capacitor, I am taking the output across both resistor and capacitor. Okay, so I can prove it to you as well. If you want to see, I can show you that. Let us do the transfer function, right? Let us do the transfer function is in Laplace domain. So this will be IIO of S. This will be 1 by Cs, this will be 1 by Cs. So basically what will be the current? So you can do the current division rule, anything you can do, right? I can directly say my current voltage transfer function I of S by II of S is simply half. It becomes a zero order circuit. What about the voltage? So my VO of S, right, is across both the resistor and capacitor, that is R plus 1 by Cs into IO of S. So your voltage transfer function is 1 plus RCS upon 2 CS. That is what your voltage transfer function is, but current transfer function is zero order circuit. So at t equal to 0 itself, the current goes to instantly half. So what is happening is that this, right, this time slot, this tau is going to 0, as it is a zero order circuit, right? This tau will reduce, this tau will roughly be equals to 0 actually. So this graph will be shifted on the left, so it will not take any time to settle. Instantly it will start, like the starting point, what is my R1 is equals to R1 equals to R2 equals to R, so this becomes half, right? And my C1 equals to C2 equals to C, so this also becomes half. So starting and ending point are same, so it does not take any time, it instantly goes to half current, and the linear increase starts instantly. There will not be any linear waveform at the starting. Okay, so what will happen now? The interesting thing is your voltage is not across the capacitor, it is across the resistor and capacitor. So initially what will happen is this, right, at t equal to 0, this will provide how much voltage? Because half current is flowing, R by 2, initial voltage will be R by 2, and from that point onwards it will be linear, because this voltage is fixed, because the current is fixed. But this voltage is not fixed because the current is constant, which makes this capacitor to increase the voltage linearly. So what will happen is that at t equal to 0 itself, my current will instantly go to half, and then it will remain at half. Okay, and here what will happen, at t equal to 0, the output voltage due to the resistor, it will shift upwards to R by 2 due to this half current, and then it will linearly increase. Okay, what will be the slope of this? The slope of this will be simply 1 by C. Okay, yeah, slope of this will be 1 by 2C actually, 1 by 2C. Okay, that is what its slope will be. So your current, right, IO of t is simply half, and your voltage V of t is simply R by 2 plus T by 2C into E of t. Okay, I hope this plot is clear. What about the impulse? So if there is impulse, if I'm applying an impulse across this circuit, right, it is simply parallel combination of these two, right? So at t equal to 0, both are equal, so delta by 2 current will flow, that will make the voltage instantly to 1 by 2C. sorry, delta, yeah, 1 by 2c, right? That will make the voltage instantly go to 1 by 2c. So the voltage instantly will go to 1 by 2c, and this voltage also is 1 by 2c. So already it is at steady state because both the potential are same. So there will not be any charging or discharging. There will not be any current flow. So at t equal to 0 itself, impulse is coming, and at t equal to 0 itself, it is settling. There is no, like, that's why that's why the time constant is 0, right? So here at t equal to 0, I will observe a impulse whose magnitude will be delta t by 2, right? After that, the current will go away, and at t equal to 0 itself, what is the voltage? Now the voltage, remember, is actually summation of both the resistor and the capacitor. Yes, the voltage here is 1 by 2c, but what is the voltage at t equal to 0 across the resistor? It is R into delta t by 2. So I will the output voltage will observe a impulse, that is R into delta t by 2. Then at t equal to 0 itself, I will observe a voltage of 1 by 2c. This will get instantly energized to 1 by 2c. Instantly energized to 1 by 2c, and it will remain at that value. It will never change. Okay. So the current graph will be, current waveform will be delta I of t will be delta of t by 2, and your voltage graph V of t will be R into delta t by 2 plus 1 by 2c into E of t. Okay. So that is what your voltage and current graphs will look like. What about the transfer function, right? Trans impedance transfer function. So what will be the trans? Now the current transfer function is half. That is very simple. So I already know what is the, like, trans impedance transfer function. We have derived that, right? We have derived that. It is this value. Sorry. Okay, this is actually, so my, like, this is not VO of S. This is actually my transfer function H of S. That is VO of S upon II of S. So 0 anyways, like, for the voltage, right? Voltage, if the voltage wants to go to 0, how the voltage can go to 0? Pole is at S equal to 0, because at S equal to 0, the voltage goes to infinity, because as S equal to 0, this is providing infinite impedance, and some finite current will flow, because through here some finite current is coming. So finite into infinity is infinity. That's why we have a pole at S equal to 0. Okay. What about the 0? For it to be 0, basically this voltage must go to 0. Okay. This voltage must go to 0, or the current through this must be 0. So if I can somehow short circuit this path, then all of the current will flow through here. So this voltage will go to 0. That's why I have a 0 at S equal to 1 by SRC, right? Basically I need to short, because these two are in basically series, right? These two are in basically series. If I short this somehow, so the voltage will go to 0. So because the current through the other branch will be 0, right? So 0 into some finite impedance is 0. So this will be 1 plus SRC equal to 0. So your SZ is basically, sorry, 1 plus R plus 1 by SZ into C will be equal to 0. So your SZ is minus 1 by RC. Okay. SZ is minus 1 by RC. So your 0 is this. Anyways, we can see directly from the transfer function itself. I don't need to derive all this. DC again at S equal to 0, right? This will provide infinite impedance. This will provide infinite impedance, and the current is, so current will be finite. That is II by 2. So the voltage, right, will be infinity times II by 2. That is infinity. That's why we have a pole at S equal to 0. High frequency again. High frequency again. Both of them will be short circuit. The current will be II by 2. II into R by 2, right? At DC, both of them will be open circuit. But still some finite current is flowing, right, through both of them, that is II into S by 2, right? So what will be the VO? VO will be basically the voltage across this resistor plus the voltage across the capacitor. What is the voltage across the capacitor? It is II of S by 2 into infinity, which is basically infinity. That means for a finite input I am getting a infinite output. That means this is the location of pole. So at S equal to 0 I have a pole, and at S equal to infinity this will behave as short circuit, this will behave as short circuit. Okay, both of them will behave as a short circuit. So then this current is what? Again, this current is II by 2. This will always be II by 2, right? II of S by 2. So what is the voltage now? The voltage at infinite frequency, this is at S equal to 0, this is at S equal to infinity, will be II of S. Basically this voltage is anyway 0, this is short circuit, this voltage is R into I of S divided by 2. So basically your high frequency gain is R by 2. That is what your high frequency gain is. That can be observed from the transfer function as well, right? Here if I put S tending to infinity, it will be RC upon 2C, that is R by 2. Okay, so this is the transfer function that we already derived. I like, we don't need to explain this much. So here, right, I will just plot the transfer function. Okay, so at S equal to 0 I have a pole, and at for very low values the magnitude will be very high. Okay, so I will start off from here. I have a pole at S equal to 0, so I will start off with a decreasing slope. Then at S equal to omega equals to 1 by RC, I encountered is 0, so the slope will become now constant. This will be minus 20 dB per decade. This will be 0 dB per decade. Okay, and this value I hope you can find out at 1 by RC, like a high frequency. What is the high frequency again? High frequency is R by 2, so this will be 20 log of R by 2. R by 2. Okay, and phase, what will be the phase? So at S equal to 0, or omega equal to 0, I am getting a phase of, I am getting a pole. So it will start off with minus 90, and 10 times before the location of the 0, that is 1 by 10 RC, I will see the effect of the 0. Slope will increase, it will go towards 0. That is 10 by RC. This will be 1 by RC. Minus 90 degree, and this will be minus 45 degree per decade. Okay, this will be 45. Okay, I hope it is clear. What about this circuit? Is this circuit different? This circuit is the same only, right? It's the same circuit. So whatever we analyzed, everything will be same. Okay, everything will be same. There is no point of discussion, right? It is same circuit only. Previously this like resistor was here, capacitor was here. So here also we are taking the voltage across resistor and capacitor, and both the R1 C1 everything is same. So same circuit as previous one. So everything will be same. Okay, I'll put it in the notes for your revision, but every single thing will be same, nothing will be different. Your output voltage will not change at all, it will be same. Pole 0, everything will be same, nothing will change. So with this we come to the end of this whole marathon. If you did enjoy, like, you can share, you can like, comment, whatever point you enjoyed the most, you can like, comment, and let me know if you want like any more videos, and if you want to have any mock interviews and stuff, you can book your mock interviews. The link will be present in the comments below. Thank you. I will see you in the next lecture. Until then, happy learning.